AIME 2023, we want to solve all 15 problems, maybe in some videos, and at the end I will release one video that contains all problems and solutions. We want to solve with logical solution, okay? The solutions that come to our mind, because it's important. We want to learn how to solve these problems in the exam. So the most important thing is to only solve the problems with techniques, strategies that are useful also for our exams. Okay, let's start problem number 1. It says 5 men and 9 women stand equally spaced around a circle in random order. So we have, let's write first M1, M2, M3, M4, M5, 5 men and 9 women. W1, W2, W3, W4, W5, W6, W7, W8, W9. The probability that every man stands diametrically opposite a woman is m over n, where m and n are relatively prime positive integers. Find m plus n. Because the problem says around a circle. So maybe you say, okay, if the circle rotates and they reach each other, you consider the same. But because here it's probability, it has no effect. You consider if the two cases can be reached to each other by rotation, they are same or not. And I will solve with both ways. You will see the answer is same. So in first case solution number 1, suppose that if two cases reach each other by rotation, they are not same. In this way, it is easier to solve, but maybe the problem was not probability, and you should know how to solve when two cases that reach each other by rotation are same. You should know how to solve that. So let's start. At first, we draw a circle, and one important point that is so much useful is that when you have something, for example, M1, M2, M3, M4, M5, consider the most limited case. Start from this. It is so much useful. So, look, all men should be opposite to a woman. Each man should be opposite to a woman. But if you consider, for example, W1, maybe she is opposite to a man or not. So we can understand that men are more limited than women. So let's start. For example, we have positions. It's first position. It's second position. Now let's see, one is opposite to what? For example, if you have 4 elements, 1, 2, 3, 4. If you have 6 elements, 1, 2, 3, 4, 5, 6. So for here, you can say 4 over 2 plus 1, 1 and 3. Or 6 over 2 plus 1, which is 3 plus 1, 4. And because we have 14, you can say 14 over 2, 9 plus 5. 14 plus 5, 8. So 1 is opposite to 8. 2 is opposite to 9. 3, 4, 5, 6, 7. Okay, 6, 5, 4, 3. And then 9, you say 10. Look, let's consider some of them. For example, 1 is opposite to 8, 2, 3. 3 is opposite to 10. 4 is opposite to 11. 5 is opposite to 12. 6 opposite to 13. And 7 opposite to 14. Now, we can say, okay, 5 is opposite to 12. And 7 opposite to 14, all these cases. Now, let's fill with M1 first. If you consider M1, We want to see M1 because it's more limited than WI. We start from this. M1 has how many cases to place? It has 14 times. Without loss of generality, let me tell you something before that. It says M over N probability. N is all cases. M is the number of arrangements the problem wants. So N is so much easy for calculate. You say 14 factorial because we have 14 places. Place number 1 has 14 cases to select between M1 to M5 and W to W9 and so on. 13. You say 14 cases, 13 cases, all arrangements. Now we want to calculate the numerator M, which is number of arrangements that satisfy the equation. The condition means for opposite to each Mi, we have Wi. So M1, 14, then, because of M1, without loss of generality, suppose M1 is in 1. Now we consider this place. We should select a woman here. So for this place, how many cases do you have? 9. Without loss of generality, consider your place W1. Then the woman, we can say the woman is opposite to this man. Now, in next case, you should select M2. Okay, so I think it's better to say M1 and the woman opposite to him. M2. Man number 2 has how many places? 12 places if you count, because we had 14 places, 2 of them were removed. So M2 is 12. For example, without loss of generality, suppose you place M2 here. Then opposite to 2 is 9. So in 9, you should place a woman, which has 8 cases. So without loss of generality, you place W2 here. Then again, M3. How many places are left? 14 minus 4, 10. For M3, and opposite to M3 is a woman. So you should select how many women are left. 9 minus 2, 7. So you multiply by 7. It's W3 times M4. You say, for example, if we want to place M4, how many places are left? If we count 8 places for M4 times the woman, how many women are left? How many women are left? 7 minus 1, 6. M4, so you place M4 W4. Now the last man, how many places are left? 6. So you say 6 for M5, and opposite to that man, how many places? How many women are left? 6 minus 1. W, for example, 5 you place. So there are 5 women that are left. So now we place all men. How many women are left? 4. We don't have any condition about them, so you can say 4 factorial for all women that are left. It is Mn. Now the problem says calculate M over N. So if you calculate M over N, it is 14 times 9 times 12 times 8 times 10 times 7 times 8 times 6. We are writing this times 6 times 5 times 4 factorial. We write 4, 3, 2, 1. Okay. Now we divide this by 14 factorial, which is 14 times 13 times 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Okay, so now it's the time to simplify. We simplify 1 to 4. We simplify 1 to 4, also 5, 5, 6, 6, 7, 7, 8, 8, 10, 10, 12, 12, 14, 14. Now the rest, if we consider 9 we have here. So for 9, we have also 9 here, 9 here, 11, 13. Okay, in numerator we have 8 and 6, denominator 11 and 13, so we can't simplify anymore. 8 times 16, 48, 8 times 6, 11 times 13, you can say 11 times 13 is 13, 13, 1, 4, 3. So we found it is this, but the problem wants what? The problem says calculate m plus n after simplify as much as you can. So m plus n is 48 plus 143. Now let's calculate this. 48 plus 143, 3 plus 8, 11. We have 1448 plus 1, 9, and 1. So the answer is 191. Okay, if we had question about, it was solution number 1 without considering that two cases reach each other by rotation. Let me tell you also if we had rotation. Before telling you solution number 2, it is if two cases reach each other by rotation, then they are same. You need this problem because maybe they don't say probability, they say calculate only numerator, the number of good cases, and if two cases reach each other, you should consider them same. Before solving this, I want to tell you two approach for calculating circular permutations that reach each other by rotation. So if we consider for three elements, I solve this with two ways, and then you will understand what should we do. Look, for example, suppose if we consider all arrangements, 1, 2, 3. You say 1, 2, 3, 1, 2, 3, 1, 2, 3. And also 1, 3, 2, 1, 3, 2, and 1, 3, 2. So this case is A. They reach each other by permutation, but you can't reach from A to B. So the answer is 2 for three cases. One approach number 1 for solving this is what? You say that you have 3 factorial, but you can rotate each case 3 times 3, it's 2 factorial. And for general, you say n factorial over n minus 1 factorial, and it's correct. But approach 2, always useful, man. Here, with both approaches, you can solve, but in many problems, only approach number 2 works. It is what? You say, okay, why these things reach to each other? The reason is because when you rotate, you will see, for example, 1 goes to 1, then 3 goes to 3, all these things. So, if you consider 1 fixed 1, rotate all cases to have 1 on top. Then you say, okay, other elements has how many cases? Other places, 2 cases, 1 cases. So, you fix 1 by 1 case, then the other cases 2, other elements 2 factorial. Or for general n, you fix 1 and other elements, you fix 1 with 1 case and other elements n minus 1 factorial. This fixing is so much useful. And in many problems, for example, when you have 3D, only approach number 2 works. Approach number 1 will be so much difficult. And here, let me explain. You say, I consider this case and this case. If you rotate any of them, the place of 1 will be bad. If we want to reach from, for example, this to this, if you rotate the first one, then it is not possible because in both cases, 1 is on top. So approach number 2 is so much important. Now, we want to use approach number 2. For this problem, both approaches, as I said before, are useful, but I want to use approach number 2, which is more important. So let's solve with approach number 2. Okay, in first step here, we know we should calculate probability m over n. The denominator is easy because you say like the thing I said, 13 factorial. You fix one of them and the others will be 13 factorial. We should focus on finding m. For finding m, we said we start with most limited cases. So we consider m1 and we consider m1 here without loss of generality and m1 on top. So we fix m1, then we've got rid of rotations. Then we can solve like previous case. You say, okay, opposite to m1, how many cases? You should select w. So you have 9 cases. Then you should select, for example, m2. For example, you without loss of generality w1. The rest will be same. For m2, you have how many places? 12, for example, without loss of generality, you place, for example, M2, let me here. Then opposite to M2, you should select one woman. 8 women are left, so you should select 8, for example, without loss of generality. Suppose you select W2. Then for M3, and opposite to him, you say, okay, 4 places are removed. 14 minus 4, 10. And opposite, for example, M3, you select here. And opposite to that, you should select a woman. You've selected 2 women and 7 women are left. So, for example, M3W3. Then for M4, you have 10 minus 2, 8 places. And for example, M4 here. And opposite to M4, you have W4. Which 6 women are left, so you select this. For M5, 6 places are left. For M5, you select this, and how many women are left? 1, 2, 3, 4, 5 women are left. So you say 6, for example, W 5 here, then 4 women, so you select 5, then 4 women are left. So you say 4 places, so 4 factorial. And if you divide, let's divide m by n, so it will be 9, 12, 8, 1 by 9 times 12 times 8 times 10 times 7 times 8 times 6, 6, 5 times 4 factorial, we write it as 4, 3, 2, 1. And then we divide this case by 13 factorial, which is 13 times 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And then we simplify 12, 12, 11, do we have 11? No. 10, 10, 9, 9, 8, 8, 7, 7, 6, 6, 5, 5, 4, 4, 3, 3, 2, 2, 1, 1, and 1 is not important. 8, 6 are left in denominator, 13, 11. 8 times 6 is 48. 11 times 13 is 143. And then it is the simplest form. M plus n will be 48 plus 143. 3 plus 8, 1, 11, 9, 1. So the answer is 191, 191. Okay, I considered both approaches, and let me tell you a homework for solving this. Similar, you should use second approach. Suppose we have a cube and the faces, you want to place 1, 2, 3, 4, 5, 6 to the faces. If 2 cases reach each other by rotation in 3D or 2D. You can rotate also in 3D space or on the plane. Or 3D, they are same. How many different cubes can we create? So try to solve this, and if you wanted to know the answer is what, feel free to send message to my WhatsApp number. This problem is so much good for getting good at approach 2, considering circular permutation, but it is in 3D, so it is a little harder. If you want to divide by something, it is hard, but if you consider fixing elements for twice, then it will be so much easier. Okay, let's jump into the next problem. Problem number 2, AIME I 2023. It says positive real numbers b is not 1 and n satisfy the equations square root of log b of n equal to log b of square root of n, and b times log b of n equal to log b of bn. So before solving this, let me tell you some rules about logarithm. At first, the definition that if, for example, log x of y equal to w, then you can say x to the power of w equal to y. The next thing, if you consider, for example, log x of yw multiply, it will be log x of y plus log x of w if you have product. And the next one, log x of w to the power of, for example, m. I use another variables not to have mistake with the variables we have in problem. It is m log. Let me also tell you this. For example, xr, you say m over r. Here we don't need this, but in some problems we need that, log x of y. Okay, so we have these points. Now around, I think 3 or 4 more rules in logarithm, 2 approaches. We will work on this, the things that the problem needs. So let's start. The first part, it says square root of log b of n equal to log b of root n. Root n is what? By definition of root n, it is n to the power of 1 over 2. Now, if we use this, r is 1 here. Here we don't have any power, so m is 1 over 2, so it will be 1 over 2 log b of n. Now here, if you simplify this part, if you raise to the power of 2, log b of n equal this part, we get rid of square root. This part will be 1 over 4 of log b of n squared. Then if we do simplify, and here maybe someone says we want to simplify. Maybe log b of n is 0, or we can simplify. We divide both sides by log b of n. So 1 equal to 1 over 4 of log b of n. And log b of n equal to 4. Okay. In this case, we conclude n is 1. Okay? So we have these two cases. Now we should focus on second equation. Okay? On second equation, we have b times log b of n equal to log b of bn. So if let's consider first case, it is case number 1, case number 2. If we consider case number 1 that n is 1, then b log b of 1 equal to log b of b times 1, which is b. So left hand side, because log b of 1 is 0, right hand side is 1. And that's a contradiction. So case 1 is not possible. We should only analyze case number 2. Log b of n is 4. Now, if we replace in this equation, let's call this one star. By star, we can say b times log b of n equal to, here we have product. So we can use this rule. So we can say it is equal to log b of b plus log b of n. So log b of b, by the definition of logarithm, if we consider this, b to the power of what is b is 1. Log b of n is what we found here is 4. Log b of n is 4, so we say here 4b equal to 1 plus 4. Okay? Now we conclude it is 1 plus 4 is what? Is 5. So b, if we divide both sides by 4, b equal to 5 over 4. We found b. But the problem says find n. From this part, you can conclude by this definition of logarithm here. You can say this approach is useful in logarithm. One approach is say change it to power exponential function. You can say b to the power of 4 is n. So b is what is b is 5 over 4. So n equal to 5 over 4 to the power of 4. And let's see the problem once. What exactly it says? Okay, the value of n is j over k, where j and k are relatively prime positive integers. Find j plus k. Okay, so n is 5 to the 4 over 4 to the 4. 5 to the 4 is 6 to 5. 4 to the 4 is 16. 2 to the 8 is 2, 5, 6. So it is j over k. Now the problem, the answer is j plus k equal to 625 plus 256. 6 plus 5, 1. We have 1. 5 plus 2, 7 plus 1, 8. 2 plus 6, 8. So the answer of this problem is 8, 8, 1. We've solved the problem. Let me tell you another rule that's useful in logarithm. If we have log b of a times log a of c, then we can say log b of c. And also another thing important in logarithm problem, in other AMC and AIME problems, you should pay attention to the diagram. It will be like this. If we have x, if we have log, for example, b of x. And also we have two types. This one is for when b is greater than 1. And the other case is when b is between 0 and 1. b cannot be negative, b cannot be 1. If b is between 0 and 1, there are these, and the opposite of this is exponential function. Exponential function is inverse function of logarithm. Again, if you want to consider, for example, you want to say b to the power of x, okay? And x, if b is greater than 1, it will be this, and it is 1. And if b is between 0 and 1, it will be something like this, between 0 and 1. Okay. So we've saw it is decreasing function, increasing function, so much useful in many problems. Okay, so we've calculated this problem completely, and the answer is 881. If you had question, as I said before, or wanted to learn how to approach logarithm problems, finding the ideas of logarithm in past AIMEs and AMCs, USAMO, and all other exams, feel free to send message to my WhatsApp number in the description and comments. AIME I 2023, problem number 3. It says a plane contains 40 lines, no two of which are parallel. Suppose that there are 3 points where exactly 3 lines intersect. It means what? 3 points that 3 lines intersect, like this. Okay, so 3 points with 3 lines. It was this board, 3 points with 3 lines intersect. So before solving this, let's read. It says 4 points, so it is first 1 point, 2 point, 3 points, and then 4 points that were exactly 4 lines intersect. So the next one, 4 points, 1, 2, 3, 4, 2, 1, 2, 3, 4. So you have how many of these? 1 to 4. Then the next one, 5 points where exactly 5 lines intersect. So you say 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then it will be 1, 2, 5. Okay, and 6 points where exactly 6 lines intersect. So 1, 2, 3, 4, 5, 6. 2, 1, 2, 3, 4, 5, 6. Okay, so look, all lines are not this. I only want to write to have better understanding for this problem, and no points where more than 6 lines intersect. Find the number of points where exactly 2 lines intersect. So for 2 lines, you say, okay, first 1, 2, we consider the number of them. 1, 2, for example, k. We have k points that 2 lines intersect, and the problem says find the number of them, means k is what? Now for this problem, we want to consider the pairs. Means what? When you have 40 lines, you have 40 lines. How many pairs are there? Like, for example, you consider L1 to L40. So if you consider the number of pairs, you say, okay, the number of pairs will be L1, L2, L1, L3. We don't say intersection. Why? Because maybe some lines have same intersections. Some pair of lines. Okay, so to L39, L40. So how many pairs are there? 40, choose 2. And other way, now we want to use these things. We have k of this. So, for example, it is Li, Lj. Each of these k intersection, because there are intersection of only 2, lines, you say k times each of them, create one pair, or you can say 2 choose 2. So this one we've calculated. Now let's consider this part. 3 lines, each of them 3 intersections. So for example, if you have LR, LSLT, so what are the pairs they create? LR, LT, then LR, LS, and then LSLT. The thing I'm doing in topics, they call it double counting. And it is useful in subsets, many problems. In tables, in combinatorics, it's so much useful. If you want to solve more problems, at the end of the solution of this problem, I will write some problems for double counting for homework. If you want to learn more, as I said before, feel free to send message to my WhatsApp number in the description and comments. Okay, L3 and LT. So here, each of these intersections contain 3 pairs. So plus we have 3 of that, 3 choose 2 or 3 plus for this one we have 4 intersections. In each intersection create has 4 choose 2 pairs. The next one 5 times 5 choose 2, and the last one plus 6 times 6 choose 2. Okay, now we have one equation, one variable, and we want to calculate this. And by this condition, because the problem says only we have these intersections, we've calculated, and we don't have parallel lines, we've calculated all pairs exactly once. So left hand side is 40 times 39 over 2. Right hand side is k. 2 choose 2 is 1. 3 times 3. This part, the next one. 4 times 4 choose 2 is 6, because 4 times 3 over 2. Look, n choose 2 is n times n minus 1 over 2. So 5 choose 2 is 5 times 4 over 2, 10. Plus 5 times 10. And this part is plus 6 times. 6 choose 2 is 6 times 5, 30 over 2, 15. And then if you simplify, it will be 20. 0, 2 times 9, 18. We have 1. 2 times 3, 6 plus 1, 7. So we conclude 780 equal to k plus 3 times 3, 9, plus 4 times 6, 24, plus 5 times 10, 50, plus 6 times 15, 90. Now, 9 plus 50, 140. 24 plus 9, 33. So it will be what? 173. And then if we subtract 173 from both sides, 780 minus 173 equal to k. And if we calculate 10 minus 3, 7. 7 minus 7, 0. 7 minus 1, 6. Okay, so k, the answer, which is k, equal to 607. And the answer is this, but let me tell you some problems for improving your double counting. The first problem, homework number 1, is suppose A and B are subsets of, for example, 1 to 10. Then in part A, how many A and B are there such that A intersect B is null set? How many A and B are there that A union B is 1 to 10? How many A and B are there such that the number of elements, this cardinal or like absolute value, 2 vertical lines for subsets, means number of elements equal to 1. How many A and B are there? Then calculate sigma of, for all A and B, A intersect B is what? Part E. For all A and B, calculate A union B is what? So look, there are lots of problems related to double counting, but one problem that is useful is this. If you want to see the other homeworks, the other problems and improve, as I said before, feel free to send message to my WhatsApp number in the description and comments, and you can send message for checking these answers. We have 5 problems here. Okay. AIME I 2023, problem number 4. The sum of all positive integers m such that 13 factorial over m is a perfect square can be written as 2 to the a. is a perfect square. It can be written as 2 to the a, 3 to the b, 5 to the c, 7 to the d, 11 to the e, 13 to the f, where a, b, c, d, e, and f are positive integers. Find a plus b plus c plus d plus e plus f. For calculating this, you should know a lemma. The solutions are similar at the end that you want to find the sum. Okay? Because of sum, you should know sum of positive divisors, or we can say an idea. Look, you should know sum of positive divisors, product of positive divisors, number of positive divisors, and also sum of, for example, even positive divisors. All these things, a lot of things, multiples of 3. There are lots of ideas. I will tell you sum of positive divisors only because it's useful here. For example, if sum of positive divisors of, for example, 24. You say 24 is what? 2 cubed times 3. Okay? So, if you consider this, let me show you. 2 to the 0 plus 2 to the 1 plus 2 squared plus 2 cubed times 3 to the 0 plus 3 to the 1. Then all divisors will be created. For example, look, 2 to the 0 times 3 to the 0 is 1 plus other things. For example, 2 cubed times 3 to the 1, 24. So the idea is this. Okay, at the end for sum. Now let's focus on the problem. We have 13 factorial over m. It should be perfect square. So because it should be perfect square, we should do what on 13 factorial? Yes, we should prime factorize. You can use formulas, but we prefer to solve it without important formulas, only with ideas. 9, 10, 11, 12 over m. So let's consider the power of 2. Let me erase 12. So it is 2 to the what? Look, 2 to the 1, 4 has 2. 6 has 1, 8 has 3, 10 has 1, 12 has 2. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It is 2 to the 10. Now let's focus on power of 3. 3, here 1, 1, 2, and 12, 1. So it will be 3 to the power of 1, 2, 3, 4, 5. Times, next one 5. 5 and 10. So it will be 5 squared. For 7, it's obvious because we have only one multiple of 7, 7 itself times 11. And the last one is, 13 factorial. So we should have 13 also here. Let me move it to right side. Okay, and so we have 13. 13 has no effect on 2, 3, 7. At the end, you should add 30. And now, because it should be perfect square, so here we have 2 to the power of something. For some 2 to the power of x times 3 to the power of y times 5 to the power of z times 7 to the power of, for example, w, 11 to the power of r, 13 to the power of q. So we have these powers. Now, because it should be perfect square, if we calculate, it will be 2 to the 10 minus x times 3 to the 5 minus y, 7, 5 to the power of 2 minus z, 7 to the power of 1 minus w, 11 to the power of 1 minus r, 13 to the power of 1 minus q. All powers should be at least 0. And we can say, it says m. Look, it says m can be written like this, 2 to the a times this. So here, and this one, 13 factorial over m, like this. Okay, it is m. Okay, so we can do something. We can write it because the problem says a, b, c, d, e, f. So we can write it like this. A, B, C, D, E, F. So it will be 10 minus A, 5 minus B, 2 minus C, 1 minus D, 1 minus E, 1 minus F. So the powers here should be even. All powers are even because it is perfect square. Even and at least 0. Even, even. Even. Now, let's focus on A, B, C, D, E. Because 10 minus A is even, so A is also even. And A can be what? 0, 2. It should be at least 0, 10 minus 8. So it can be 0, 2, 4, 6, 8, 10. B should be even. So B, 5 minus B should be even, so B is odd. And B can be 1, 3, 5. 2 minus C even. So C should be even. So C is 0, 2. 1 minus D should be even. So D should be odd, and the only possible case is 1. Okay, D should be odd, and the only possible case is 1. Similarly, E should be odd, 1. F should be odd, 1. And it says calculate all things like this. Because the power of 2, the sum of them, we should use exactly the thing in of the solution. I said sum of positive divisors equal to what? Here we should do the same thing. We say, okay, A is the power of 2, so because we want to calculate sum, you say A can be 0 or 2 squared plus 2 to the 4 plus 2 to the 6 plus 2 to the 8 plus 2 to the 10. And for B power of 3, it can be only 1, 3 to the 1, 3 to the 3, 3 to the 5 times C is power of 5, 5 to the 0 plus 5 squared. For D, 7 to the 1, 11 to the 1, 13 to the 1. So some of them is this. Let's see the problem says remainder or not. Find A plus B plus C plus sorry, it says calculate the sum. Sum can be written like this. So it is not A, B, C, D. A, B, 2 to the A, this is sum of all of them. So you can change it to this prime. A prime, B prime, C prime. It says the last answer can be written like 2 to the A. And this, so it will be this. Now, we should calculate this last answer, and we should write this as 2 to the A, 3 to the B, 5 to the C, 7 to the D, and 11, 13, 11 to the E, 13 to the F. And then find A plus B plus C plus D plus E plus F. So let's calculate the first one. Let me tell you a formula in general that you should memorize. If we have 1 plus R squared to R to the N. There are around 5 basic formulas. One of them is this. You should memorize them. If you want to know the others, I said before, feel free to send message to my WhatsApp number in the description and comment. So in this case, 2 to the 0 to 2 to the 10. We can say because it's 1, 4, 4 squared. Here, R is 4. Because look, it is 1 plus 4. The last one is 4 to the 5 or 2 to the 10. So N is 5. So here it will be 4 to the 6 minus 1 over 4 minus 1. If you use the formula. The next one, let me write below each case. Here we can calculate without formula because 3 is 3. It's 27. 3 to the 5 is 243. So it's 250 to 72, 73. Okay. Times the next one. The next one is 5 to the 0, 1 plus 25, which is 26. The next one is 7, the next one is 11, the next one is 13. Now let's simplify more. 4 to the 6 minus 1 is what? Is 2 to the 12. 2 to the 12 is 4096 minus 1, 4095 over 3. Times 273 is 9. Or we can simplify 3 times 91 times 26 is 2 times 13 times 7 times 11 times 13. Now, if we divide 4095 by 3, it will be 1, 3, 6, 5 times 3. We can write 91 as 7 times 13 times 2, 13, 7, 11, 13. So let's focus only on first number. We see that this number is it multiple of, it's multiple of 5 first. We can say 2 times 5, 10, 36, 7 times 5, 15, 3. And again, 273 like this is 3 times 91, 3 times 7 times 13. So it will be 5 times 3 times 7 times 13 times 3 times 7 times 13 times the rest. 2, 13, 7, 11, 13. And then the power of 2 here. It's 2 to the power of 1. We've finished this. Times 3, 3, 3, 1, 3, 2 threes. So 3 squared. Okay? Now let's consider on 5. 5 we have times 5 to the power of 1. Now let's check 7. 7, 7, 7. We have 7, 3, 7. So 7 cubed. The next one. 11. We have 1, 11. Okay. 11 to the power of 1 and 13. 1, 13, 2, 13, 3, 4. 13 to the power of 4. And we should calculate the powers here. Problem 5. So let's consider it is A, it is B, it is C. The problem says D, E, F. So we conclude sum of A plus B plus C plus D plus E plus F equal to 1 plus 2, 3, 3 plus 1, 4, 4 plus 3, 7, 7 plus 1, 8, 8 plus 4, 12. AIME I 2023, problem number 5. Let P be a point on the circle circumscribing square ABCD. So let me draw. Here we have a square ABCD, and this is circumscribed circle. Now it says P is on this circle such that PA times PC 56, PB times PD 90. Find the area of ABCD. Okay. Okay, so let's consider P, for example, is some point here. It is PBPD, which is 90, the product, and next one is PCPA, which is 56. Okay. Now, because we have these two relationships, at first let's work on the angles, okay? Now, the first angle I want to tell you, for example, suppose this angle is alpha. So because of inscribed angle, this angle is this arc over 2. So this arc will be 2 alpha. And because we have square, so the whole circle is what? 360. So we divide by 4 because it is a square. All of them are equal. 360 divided by 4 is 90. So it is 90, it is 90, it is 90. And this part will be 90 minus 2 alpha. So if I want to find other angles here, I can say, let me select, minimize this, 45 minus alpha. This one is alpha. This angle is 45 minus alpha. This angle we know is 90. This angle 90. And now we want to write something that relates, for example, PA, PC, all these things together. Because we have product, sometimes you can consider division, for example, PA over PB. And when we want to work with division and product of length, one important thing is sine law. So let's see how we can use this. Look, I have two green lines, PAPC, two pink lines, PBPD. They are important. So I use Pythagorean theorem, for example, in triangle PAD. So let me write. Let's use sine law first. In triangle, for example, PAD, PBC. So let's write in PBC first. PB over sine this, 45 minus alpha, equal to PC, this length, over sine 90 plus alpha. Okay, sine 90 plus alpha. Now in next step, you use again sine law in triangle PAD. So because PBPD, you write PD here over, let's see, we should write sine what? This part, 90 plus 45, 135 minus alpha, sine 135 minus alpha, equal to PB, sorry, PA over sine alpha. Now we multiply these two equations. The left side will be PB times PD, and it's good because we know it's 90 from assumption of the problem, times sine 45 minus alpha sine 135 minus alpha equal to PC times PA over sine 90 plus alpha sine alpha. That's so much good. Why? Because we know PB times PD by here is 90. PC times PA is 56. Okay? So let's replace them. And then in next step, we can say, okay, let's write sine. If we cross multiply, let's first cross multiply. At first, we can divide both 90 and 56 by 2. Here it will be 45, here it will be 28. So if we cross multiply 45 sine 90 plus alpha times sine alpha equal to 28 sine 45 minus alpha sine 135 minus alpha. From this part, you should know something about trigonometric things at first. Sine 90 plus alpha is what? Look, if you have two angles, for example, sine theta and 180 minus theta, their sine is equal. Sine 180 minus theta equal to sine theta. Exactly. If we apply this, 90 plus alpha plus what angle is 180? Sine 90 minus alpha. So the first thing is this. The next rule, sine 90 minus theta equal to cos theta. Okay? So this part equal to cos alpha. Now, again, if I use this, 180 minus theta, theta, sum of them 180, sine of them equal, this plus what? 135 minus alpha is 180, 45 plus alpha. Okay, so let's rewrite this. 45 cos alpha, sine alpha equal to 28, sine 45 minus alpha, sine 45 plus alpha. Okay, so sine alpha, cos alpha. Another formulas in trigonometry. Look, there are around 10 important formulas you should know in trigonometry. They are useful in AIME, AIMC, also harder exams, IMO. If you want to learn them, feel free to send message to my WhatsApp number in the description comments. So when you have cos alpha, sine alpha, we have an important rule. Also, it is a special case of another identity. But sine 2 theta equal to sine theta cos theta. So here, if you divide by 2, sine 2 theta over 2 equal to sine theta cos theta. Now, here you say sine alpha cos alpha equal to, by this rule, sine 2 alpha over 2. Now, we want to know this. For knowing this, you should consider product of two sines. Okay, now here, when we have two sines, for example, sine beta, sine theta. The formula is, you say 1/2, let me move it here, cos beta minus theta minus cos beta plus theta. You have this formula. Now let's apply it here. Sine this, it will be 1/2 times cos the difference. For example, it is not important you say cos this minus this or this minus this, because in cos, we know cos negative theta equal to cos theta. So cos the difference 45 plus alpha minus 45 minus alpha. So it will be what? The difference? It will be 45 will be cancelled. It will be 2 alpha. Minus cos their sum. 45 minus alpha plus 45 plus alpha, which will be 90. Cos 90 is what? Is 0. So if we multiply both sides by 2, we can cancel this to 1/2. So 45 sine 2 alpha equal to 28 cos 2 alpha. Now, why this alpha important? Why? Because here, look, we considered sine rule. We've not written third part. Now we can write. In triangle PBC, can you tell me the third fraction is what? Let's consider this A. And also this A, it is a square. So in PBC, it will be A over sine. This angle is what? 90 over 2 inscribed angle, 45. Also this one, 45. So it will be A over sine 45. And this one also will be A over sine 45. So when we multiply these things, here also we will reach A half sine squared 45. Okay? And here we want to find sine alpha, sine 2 alpha, then we can focus on this part. And we've concluded this part. Let me write here sine 45 minus alpha, sine 135 minus alpha, this part. When we've calculated this, it was 1/2 cos 2 alpha. So we can say it is equal to 1/2 cos 2 alpha. So if we find, for example, cos 2 alpha, we replace it here and we can find a squared. So let's calculate here. We can do something. We can raise here the power of 2. 45 squared times sine squared 2 alpha equal to 28 squared cos squared 2 alpha. Why we've done this? Because we know that sine squared 2 alpha plus cos squared 2 alpha equal to 1. So because we want to find cos 2 alpha, we say, okay, sine squared 2 alpha equal to 1 minus cos squared 2 alpha. And if we replace it here, it will be 45 squared 1 minus cos squared 2 alpha equal to 28 squared cos squared 2 alpha. Now, we want to find cos squared alpha. So, if we expand this part, it will be 45 squared minus 45 squared cos squared 2 alpha equal to 28 squared cos squared 2 alpha. So, if we take it to right hand side, then we can say 45 squared equal to cos squared 2 alpha times 28 squared plus 45 squared. Now, we can consider that cos squared 2 alpha equal to 45 squared over 28 squared plus 45 squared. Then it will be, if we consider a square root, cos 2 alpha. Let me tell you something. Because look, 2 alpha is from 0 to 90, so cos 2 alpha is positive. Okay, because look, this arc is 90. 2 alpha is between 0 and 90. Between 0 and 90, both cos and sines are positive. So cos 2 alpha equal to 45. We consider square root over, we don't consider plus minus, only plus, because as I said, 2 alpha is between 0 and 90. 45 squared. Now here, we should calculate the square root of this part. So let's calculate 28 squared first. If we want to find 28, 8 times 8, 64, we have 6. 8 times 2, 16, plus 6, 22. 2 times 28 is 56. So it will be 4, it will be 8, it will be 7. Next part, we want to multiply 45 by 45. 5 times 5, 25, we have 2. 4 times 4, 20, it will be 22. 4 times 5, 20, we have 2. 4 times 4 plus 2, 16 plus 2, 18. So it will be 5, 2, 0, 2. Okay, now we add these two things. 5 plus 4, 9. 2 plus 8, 10. We have 1. 7 plus 0, 7 plus 1, 8. 2, we have 2. Okay, now I want to find square root of this. It has an algorithm. You can easily calculate this. In AIME problem also, I told this algorithm. From right, you divide digits 2 by 2, then you say 28. You write 5, 25, 3, you consider next two digits, you multiply this by 2, 10. Then you should place same digit, 3, 309. 0 is 53. If you want to learn this algorithm that is so much important in AMC, AIME, and next levels, feel free to send message to my WhatsApp number in the description and comments. Okay, so cos 2 alpha equal to 45, and the denominator is 53. Now, let's review this part again. 45 over 1 half cos 2 alpha. Let me write 45 over 1 half cos 2 alpha equal to a squared over sine squared 45. A squared over sine squared 45. Now, sine 45 is what? Is root 2 over 2. Sine squared 45 is root 2 over 2 squared, which will be root 2 times root 2 over 2 times 2. Here you can cancel and it will be 1 over 2. So it will be a half times 1 over 2. You can cancel these two things, and then you can say, okay, a squared is 45 over cos 2 alpha. Cos 2 alpha is what? 45 over 53. So you can say 45 times, you should reverse cos, because cos 2 alpha, because it is in the denominator. So it will be 53 over 45. And if we cancel, it will be 53. The problem wants the area, and we know now the area of this problem, which is a squared equal to 53. Let me tell you something, only this part. Here, look, it is 90, this part, because we divided by 45, it was only for this fraction. So it is 90 here. 90 over 1 half cos 2 alpha equal to a half over sine squared 45. So let me change 45 to 90. This one, 45 to 90. Then, if we write here, 90, it will be 2, and it will be 106. Okay, so the answer is 106. Look, always after solving the problem, try to review things. If you had careless mistake, try to find. If in the problem you can check your answer, do this. Okay, so the whole solution is exactly these trigonometric things. It has also another solutions, but it was one of the logical way. And this part, so you should pay attention when you have something like this calculation of things. When you consider two fractions and you have another fraction, you should pay attention to all fractions simultaneously. Okay, if you had questions, send message. As I said before, feel free to send message to my WhatsApp number in the description and comments. AIME I 2023 problem number 6. Alice knows that 3 red cards and 3 black cards will be revealed to her one at a time in random order. Before each card is revealed, Alice must guess its color. If Alice plays optimally, the expected number of cards she will guess correctly is m over n, where m and n are relatively prime positive integers. Find m plus n. So first, let me tell you something. The formula of expected value is this. So E of x equal to sigma x times probability of x equal to x. It means what? For example, suppose you have 2 games. You win $100 here, this game, by probability. You win $100. If you lose, for example, you lose $50. Okay. And the probability here is 1 half, here is 1 half. So if you want to find expected value of the price you will give is 1 half, you win $100. The probability, look, probability times the thing you get plus the probability that you think you can get here, it will be 50 minus 25, 24. So it is something like this. Now we want to solve. Here we have 3 reds, 3 blacks. As I said in AMC, the most important idea, and also it's useful in AIME, you should consider a small example. So here we have 3 reds, 3 blacks. At first, I want to consider only if we have 1 red. So here, the expected value, she guessed red because she knows only we have 1 red. With probability of 1, she can guess 1 card right. So it will be 1 times 1, 1. Now suppose, for example, we have 2 reds. Expected value in first step by probability of 1 she gets the first one. The next step by probability of 1 she gets the next one too. If we have, for example, 3 reds, then again similarly it will be 1 times 1 plus 1 times 1 plus 1 times 1 equal to 3. Now let's consider another cases. So if you have RB, the first one she gets by probability of 1/2 is correct because both of them are equal. She gets red or blue. So 1/2, the probability she gets right the first one, and then after that, for example, it is not important she gets, for example, red or black. Then next one is correct always because by probability of 1/2, if the first one was red, now we have blue. By probability of 1/2, the next one is R. Here it's 1. She can guess the expected value is 1 here. So the expected value here is 1/2 plus the next one 1/2 times 1 plus 1/2 times 1, which will be 1/2 plus 1, which is 3/2. Now let's consider if you have 2 reds, 2 blues. Okay, now here, because she plays optimally, and she must guess its color here. If she says the first one, she says red because we have 2 more. So expected value is the probability 2/3. She says red times 1. Then in next step, by probability of 2/3, the first one that is revealed is R. So then we have RB. By probability of 1/3, the first one that will be revealed is B. So we have RR. Now here, we know when we have RB, the expected value is 3/2. When we have RR, the expected value is 2. So here, expected value is 2/3 plus 2/3 times 3/2. This times this plus 1/3 times 2 plus 1/3 times 2. Now, if we cancel, here it will be 1, 2/3 plus 1 plus 2/3. If we use common denominator 3, it will be 2 plus 3 plus 2. 2 plus 3, 5 plus 2, 7. 7/3. Now in next step, consider we have 2 reds, 2 blues. Okay? 2 reds, 2 blues. The expected value here. The first one, she gets red or blue, so it can say 1/2 times. Okay, we multiply 1/2 and times 1, the first guard, plus. Then with 1/2 we reach 2 R's and 1 B. And with probability of 1/2 we reach R and 2 B's. So we calculated this part, expected value is 7/3 in both cases, 7/3. So if we calculate expected value, it will be 1/2 plus 1/2 times 7/3 plus 1/2 times 7/3. Now, sum of these two parts you can factor from the first one 1/2. The next part you can factor from 7/3. It will be 1/2 plus 1/2 1, 7/3. If we use common denominator 6, it will be 3 plus 2 times 7, 14. So it will be 17/6. So expected value of this part, 2 R's, 2 B's is this. Now let's consider 3 R's, 2 B's. Equal to. The first one, she says R because we have 3. Optimally means she should say R. So the probability is 3/5 times 1 plus. We have 3/5. With probability of 3/5, R will be revealed. 2/5, B will be revealed. And here the next step is 2 R's, 2 B's. And here it's probability 2/5, B will be revealed. So we have 3 R's and 1 B. And here the expected value is 17/6. Here 3 R's, 1 B, the expected value. 3 R's, 1 B, we've not calculated yet. So let's do something. Let's move it down and let's calculate 3R's 1B first. 3R 1B. So expected value. She says R because optimally 3 over 4 times 1 plus the probability of 3 over 4 R will be revealed. And next step will be 2 R's and 1 B. With probability of 1 over 4 B will be revealed. Then we have 3 R's. So 2R 1B is what here? 2R 1B is 7 over 3. 3 R's we've calculated. Let me show you here, which is 3. So we have 3. So expected value will be 3 over 4 plus 3 over 4 times 7 over 3 plus 1 over 4 times 3. Now here it will be 3 over 4 plus 7 over 4 plus 3 over 4, 3 plus 7, 10 plus 3, 13. So it will be 13 over 4. Now here that we've calculated this, 3R's 1B is 13 over 4. And the expected value here is what? Is 3 over 5 plus 3 over 5 times 17 over 6 plus 2 over 5 times 13 over 4. Now we should simplify this part. How? Look, 3, 6, 2, 2, 2, and then it will be, we use common denominator 10, 2 times 3, 6, plus 17, plus 13. And then, next step, 13 plus 17 equal to 20, 20 plus 6, 26 over 10. If we divide by 2 both numerator and denominator, it will be 13 over 5. Now it's the time to consider 3 reds and 3 blues. So let's write. We have 3 reds, 3 blues. So the first one, she says by probability of 1 over 2 will be correct, plus by probability of 1/2, she selects R, and they are similar. You don't need to write both of them, but I want to explain more for students that their problem solving is not as much as good as professional students. So it will be, if 1/2 probability, we select R with probability of 1/2, R will be revealed or B will be revealed. So here we've calculated when we have 3 R's, 2 B's, expected value 13 is 13 over 5. So it will be 13 over 5, it will be 13 over 5. So expected value here is 1/2 plus 1/2 times 13 over 5 plus 1/2 times 13 over 5. And it will be 1/2 plus, if you factor from 13 over 5, it will be 1/2 plus 1/2, which will be 1. 13 over 5. Now, if we use common denominator 10, it will be 5 plus 2 times 13, 26. So it will be 31 over 10. Let's calculate again. Let me just correct this one. 13 plus 17 is 30. Okay? 36. So it will be 18 over 5. So let me correct these 13s by 18. So the next one, this one. 18 over 5, 18 over 5. So it will be 1/2 times 18 over 5. And the last one is also 18 over 5. So it will be 18 over 5. It will be 5 plus 36, which will be 41 over 10. Now it is M O N N. The problem says, and M and N are relatively prime. 41 and 10 are relatively prime. They don't have any common factor. The problem says find M plus N. You say 41 plus 10, which will be 51. Okay, so our answer is this. If you want to learn these things, and you could also solve easier, but I prefer to tell you the solutions that are logic that all students can understand. If you want to solve these types of problem with efficient way, recursive sequence, all the important things that are useful also up to IMO, feel free to send message to my WhatsApp number in the description and comments. AIME I 2023 problem number 7. It says call a positive integer n extra distinct if the remainders when n is divided by 2, 3, 4, 5, and 6 are distinct. Find the number of extra distinct positive integer less than 1000. So let me tell you something. It says it should be different mod these things. So, for example, when we have a number n divided by 2 mod 2 mod 3 mod 4, for example, 1, 2, 3, 4, 5 different numbers, mod 6, 2, 3, 4, 5. So I forgot writing 4, mod 4. All of them should be different. And we can say when we have these, we can determine n mod LCM of this number. LCM of these numbers is 2, 3, 4, 5, 6. So the maximum power of 2 is 4 times 3 times 5, which will be 4 times 3, 12 times 5, 60. So mod 60 is important. We should find n mod 60 is what? So we should only check 1 to 60, and then because of 1000, 61 to 120 is same as 1 to 60. Now, we can reject some cases. For example, it says they should be what? Distinct, different. So for example, if you have 0, 0, it's bad. Let me tell you something. If n, for example, is 0 mod 2, and n is 0 mod 6, mod 3, it's bad. Because they are same. And we know that it is equivalent that add mod 6 is 0. Look, considering different mods, and then, for example, change them to one mod. It has two tricks and two ideas. Both of them are useful. If you want to learn them, as I said before, feel free to send message to my WhatsApp number in the description and comments. So, n mod 6 0 is bad. Similarly, if you consider 2 4, LCM is 4. So, let's consider what remainders are bad. Mod 4, mod 2 and 3, mod 6. Let me write all of them here. Because our numbers are 2, 3, 4, 5, 6. 2 and 3, mod 6. Mod 6, 0 is bad. Bad numbers. We want to analyze them. 2 and 4 is mod 4. Mod 4, 0 is bad. 2 and 5, mod 10, 0 is bad. 2 and 6, mod 12, 0 is bad. 2 and 6 will be 6, sorry. So, 0, mod 6, 4, and 10 are bad. Also, similarly, we can say if it is 1, 1, mod 2 is 1. Okay, so also if you consider 1, 1 here, then it is equivalent to 1 mod 6. So, 1 is bad, 1 is bad, 1 is bad here. We consider these numbers, and the next thing also, we consider mod 4, we consider mod 6, we consider mod 10. For example, 20. If we consider 4 and 5, mod 20, 0 is bad. Because 4 and 5, the remainder can be 0, 1, 2, 3. Because of 4, 1, 2, 3, all these numbers are bad. Because if mod 20 is 0, 1, 2, 3, then mod 4 and 5, it will be equal. Mod 12 also we can say. Mod 12 is when we consider 4 and 6, their LCM is 12. So 0, 1, 2, 3, all these numbers. Now I write 1 to 60, and I want to reject all numbers that are bad. Let me write with black. We write 1, for example, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, the last one 55, 56, 57, 58, 59, 6. Okay, let's reject. So first, mod, for example, 401 is bad. Let's apply this one, mod 401. So it is bad, it is bad. The next one, 89 is bad. The next one, 12, 13 is bad. 16, 17 is bad. 20, 21 is bad. 24, 25 is bad. 28, 29 is bad. 32, 33, 36, 37, 40, 41, 44, 45, 48, 49, 52, 53, 56, 57, 60. We've applied mod 4. Okay, now let's apply mod 601 are bad. So 6, 7 bad, 12, 13 bad, 18, 19 bad, 24, 25, 30, 31, 36, 37, 42, 43. Okay, 48, 49, 54, 55. So we've 60. We've applied mod 6. Now mod 1001 is bad. So 10, 11, 20, 21, 30, 31, 40, 41, 50, 51, and 6. So we apply this. Mod 20, 0, 1, 2, 3 bad. So 1, 2, 3 here is bad. 20, 21, 22, 23 is bad. 40, 41, 42, 43 is bad. And we finish. Mod 12, 0, 1, 2, 3 is bad. So 12, 13, 14, 15. They are bad numbers. 24, 25, 26, 27 is bad. 36, 37, 38, 39 is bad. And 48, 48, 49, 50, 51, they are bad numbers. So let's see what numbers are left and let's check them. The numbers that are left are here, no number, no number, no number. The first number, 34, 35, that we should check. 46, 47, 58, 59. Now we should consider mod 2, mod 3, mod 4, mod 5, mod 6. We should fill these places. So 34 is 0 mod, this 3 here is 1, 34 is 2, it is 4, 30 is 4. So it is bad because these two 4s are not different. 35 is 1 here, mod 3 is 2, mod 4 is 3, mod 5 is 0, mod 6 is 5. So this is good, all numbers are different. 46 here is 0, 4 plus 6, 10 is 1, mod 4 is 2, mod 5 is 1. Again, it's bad because we have two 1s. 47, mod 2 is 1, mod 3, 4 plus 7, 11 is 2, mod 4 is 3, mod 5 is 2. Again, it's bad because mod 3 and mod 5, 2. 58. 58 mod 2 is 0, mod 3, 5 plus 8, 13, 13 is 1, mod 4, 56, 2, mod 5, 3, mod 6 is 4. So it is again good number. 59 is 1 mod 2, 5 plus 9, 14 is 2 mod 3, mod 4, 56, 3, mod 5, 4, mod 6, 4, 5. Okay, so we found 3 good numbers. So the numbers that are good, 60Q plus 35 is good, plus 58 plus 59. And the problem says find from what positive integers less than 1000. So they should be greater than equal 1, less than or equal 999. So we know from 1 to 960, it is multiple of 60. 960 divided by 60, it will be 16. So we have 16 groups of complete parts. So in each 16 groups, we have 3, all 35, 58, 59. And the last one is from 961 to 999. So we can have 35, but it is equivalent 1 to 39. Okay? So from 1 to 39, only 35 is good. So one good number in the last box. So it will be 48. 3 times 16, 48, plus 1, 49. Okay. So look here, we have a lot of things in modulo that are important and basic. You should learn them. If you want to learn important ideas that are important in number theory and are useful from round 1 AMC up to IMO. The hardest level, as I said before, feel free to send message to my WhatsApp number in the description and comments. AIME I 2023 problem number 8. Rhombus ABCD has BAD less than 90. So BAD less than 90. There is a point P on the incircle of the rhombus such that here the distance from P to the lines DA, look, DA is 9 respectively, because so look, P from DA here it is 9. P from AB is here is 5. And it's 5. P from BC, this part is 16 respectively. Find the perimeter of ABCD. So here the first thing we can say the height of rhombus KF and also EL. We know because it is rhombus EL equal, look, because EL equal to this, and KF you can say it is this equal to this, and you can easily say these two triangles are congruent because this angle by two angles on the side. So we can say also by symmetry, you can say EL is height of rhombus equal to KF. So EL is what? Is 9 plus 16, 25. KF is what? 5 plus PF. So we conclude PF is 20. So the first thing we can say is PF equal to 20. Now here we want to analyze the other lengths. So here we can consider, for example, M perpendicular here, and this part, it will be, let me tell you, here it's 60, 150, it is this part, so it is center, and this part is radius. And because if you extended this part, we have this, so it is R, 2 times radius equal this height, 16 plus 9, which is 25. So R equal to 25 over 2. Now I want to find, I know, let me erase this part. I want to say why EM is 12, okay? If we extend this, R is 25 over 2. So it is 9. So let me tell you, 20 is for what? 20 is for PF. It is 9, this part. The whole part is R. So it is R minus 9. And this part is R. And for example, let's call this one PT. So by Pythagorean theorem in triangle OTP, we know OP squared equal to OT squared plus PT squared. OP squared is R squared. OT squared is R minus 9 squared. Plus PT squared. Okay, and we know PT equal to EM. So we can say R squared equal to R minus 9 squared is R squared minus 2 times R times 9, 18R plus 81 plus PT is what is EM squared. You can subtract R squared from both sides, and then you can conclude EM squared equal to 18R minus 81. R is what? Here, 25 over 2. So EM squared is 18 times 25 over 2 minus 81. 2 times this 9. Now we can factor from 9. It will be 25 minus 9, which will be 16. So it will be 9 times 16. So EM, if you take square root, is 3 times 4, which is 12. Okay, now we know this length, EM is 12. We want to analyze the length to see what can we reach. Okay, now we want to use same proof to find, for example, let's consider this point N, to find Kn. Look, in geometry, there are around, as I said before, 40, 50 formulas you should learn. If you want to know them, feel free to send message to my WhatsApp number in the description and comments. And look, in this problem, we only need to use Pythagorean theorem, something like this. So, like EM, try to find Kn first by yourself. pause the video and try to find it by yourself. So look here, let me erase this part. So Kn. Now let me also erase this part because we don't need these parts anymore. We found Em. Now for this part, again, I draw perpendicular here, okay? And we know this part is odd, this part is 5, this part is r minus 5, and for example, we can call this one PL, okay? So PL is in triangle OLP. If we use Pythagorean theorem, r squared equal to r minus 5 squared plus PL squared. So here r squared plus r squared minus 10r plus 25 equal to PL equal to Kn plus Kn squared. Again, we cancel r squared from both sides and Kn squared equal to 10r minus 25. R is what? 25 over 2. So it will be 10 times 25 over 2 minus 25. Now, if we simplify, it will be 5. 5 times 25, 125 minus 25, 100. So we conclude Kn equal to 10. Okay, so we found Kn also equal to 10. Let me erase all these things. We don't need them anymore. Now we try to write equal lengths. So here, look, for example, this length is x, this length is x. Because from a point, if you draw two tangents, the lengths are equal. This length is y, this length also dm is y. For example, this length is also z. So because this part is 10, we've calculated, it will be z minus 10. This part is z. Because it is 12, it will be z minus 12. Now let's analyze the rest. Now we want to use Pythagorean theorem in APK and APE. So let's write. If we use Pythagorean theorem in APK, then we can conclude. Z minus 10 squared plus 5 squared equal to AP squared. And if we use Pythagorean theorem in APE, Z minus 12 squared plus 9 squared equal to AP squared. Then if we subtract, or let's not subtract, we can say AP squared, they are equal, so we can conclude Z minus 10 squared plus 5 squared equal to Z minus 12 squared plus 9 squared. Okay, so here it will be Z squared minus 20Z plus 100 plus 5 squared, which will be 25, equal to Z squared minus 24Z plus 12 squared, which is 144, plus 9 squared, which is 81. Now we cancel Z squared from both sides. 24, you take it to left hand side. 24Z minus 20Z, 4Z. And then we take these two things to right hand side. 144 minus 144, 81 minus 25. Okay. This part 1 plus 4 is 5. 8 plus 4 is 12. So 125 minus 25 is 100. So Z equal to 25. Okay, now we can replace this Z with 25. 25 minus 10 here will be 15. And 25 minus 12 will be 13. Okay, so let's erase this part. Okay, now we consider, for example, this length is t, this length is t. Again, we want to use similar Pythagorean theorem. Let's consider first in BP, let's say PLC. Pythagorean theorem in PLC. So PL squared plus LC squared equal to PC squared. And if we write PCF, then PD squared plus PF squared plus FC squared equal to PC squared. And they are equal, so we can conclude PL squared plus LC squared equal to PF squared plus FC squared. Okay. So PL is what? 16. So this part is 16 squared. PF is what? 20. 20 squared. Now LC. LC is what? LC here we have T, and this part is what? Look, you can draw this thing, and if you draw exact O, for example, here, you can say because it is 90, it is 90. So EM equal to this part. So we can conclude that this part is 12. Okay, so 12 plus T. So let me write it 12 from here. So LC is T plus LC squared is T plus 12 squared. Now last part, PF. PF, look again, I want to use same thing. So if I consider PF, we know is, sorry, PF is 20 squared, not FC. So if I consider FC, this part is T. We want to focus on this part. If you draw exactly same thing again, this is 10 rectangle. It is 90. It is 10. So let me write it again. This part is 10. So FC will be T plus 10 squared. Okay. So we reached this. So let's replace. We have 16 squared plus T plus 12 squared is 16 squared is 256. Let's write all of them. 256 plus T plus 12 squared is T squared plus 24T plus 144. 20 squared is 400 plus FC squared is T squared plus 20T plus 100. You subtract T squared from both sides. You take 22 to left hand side. 2040 minus 20T is 40 equal to 100, 400, 500, okay, minus 144, 256, minus 144 plus 256. Okay, so 300, 400, it will be 400. 500 minus 400 is 100. So if you divide by 4, T is 25. So let's apply this T here. It's 25 and 25 here. Okay, now here we use another Pythagorean theorem to find x. Because I want to find x, for example, let's consider this part Q. Now I want to use Pythagorean theorem again in triangle LPQ. If I find x, then it will be okay, x plus 25, and we multiply it by 4 to find the perimeter of rhombus. So in LPQ, we can say LQ squared plus LP squared equal to PQ squared. Now, other Pythagorean theorem is in triangle. Let me see. I think it's better to draw this part. P to B. Okay. So let's erase this part. LPB. If we use Pythagorean theorem in LPB, LB squared plus LP squared equal to BP squared. And the other one is BKP. BK squared plus KP squared equal to BP squared. Because BP is same in both of them, so we can conclude LB squared plus LP squared equal to BK squared plus KP squared. LP is what? So let's consider. LP is 16. 16 squared. Sorry, LP, 16 squared. LB is what? We know it is 12, it is x, so it is 12 minus x squared. The next one, BK. BK is what? 10x, 10 plus x squared. KP is what? Is 5. It's 5 squared. Okay, if we expand, it will be 12 squared, which is 144, minus 2 times 12 times x minus 24x, plus x squared, plus 16 squared, which will be 256, equal to 10 plus x squared 100, plus x squared plus 2, times 10 times x 20x plus 5 squared, which is 25. And then we can subtract x squared from both sides. 144 these numbers. So let's do something. Let's take 24 to right hand side. So it will be 24x plus 20x. And let's take the numbers, all numbers to left hand side. So it will be 144 plus 256 minus 100 minus 25. So now here, left hand side 24 plus 20, 48, 4x. 144 plus this part is 400 minus this 300 minus 25 is 275. So x equal to what is 275 divided by 44. If you divide both numerator and denominator by 11, it will be 4. It will be 225. Now, the answer is what? Perimeter of rhombus ABCD is what? Is 4 times x plus 25. X plus 25. X was what? 25 over 4. 4 times 25 over 4 plus 25. We multiply 4 by the first one. That will be 25 and 4 by second one. 100. So the answer will be 125. Okay, so we found the lengths. We've used Pythagorean theorem. So working on Pythagorean theorem is so much useful, and also Carnot's theorem and some other things in 3D also useful in past years of AIME and also in AIMC. If you want to learn, for example, double Pythagorean theorem in 3D, Carnot's theorem, the important things related to Pythagorean theorem, the base of all these things is Pythagorean theorem. If you want to learn those ideas, as I said before, feel free to send message to my WhatsApp number in the description and comments. AIME I 2023, problem number 9. It says find the number of cubic polynomials p of x equal x cubed plus ax squared plus bx plus c, where a, b, and c are integers in negative 20 to 20, such that there is a unique, this unique is important, integer m that is not 2 with p of m equal to p of 2. So first we write exactly what problem wants. Okay, p of m equal to p of 2. So we only replace in p of x. P of x is x cubed plus ax squared plus bx plus c. So we can say m cubed. We replace x with m on left hand side plus am squared plus bm plus c equal to, in right hand side we replace x with 2. It will be 8 plus 4a plus 2b plus c. Now we can cancel c from both sides. And we take all things to left hand side. Okay, so it will be, because we know p of 2 equal p of 2. We know one answer for m is 2. So we can factorize then. So we say m8 minus 8 plus am squared minus 4. If we take all things to left hand side. Plus b times m minus 2 equal to 0. Okay. Now, because we know m2 is one root, we can factorize, and one factor is m minus 2. For first part, you should know this factorization, that a cubed minus b cubed is a minus b times a squared plus ab plus b squared. You should memorize it. Also, you should know a squared minus b squared should be a minus b times a plus b. If you don't know these two identities, you should memorize. For first part, it will be m squared plus 2 times m plus 2 squared, which is 4. For next one is a times m plus 2 plus b equal to 0. Okay, so we know this part, m2 is the answer if it is 0. The product is 0, so this part is 0 or this part is 0. So for the first one, we know m equal to 2. But the problem says m shouldn't be 2, and it's unique. So this part m2, now let's analyze this part. So we have m squared. Let's write it's a quadratic equation in terms of m. If we rearrange, it will be m times 2 plus a plus 4 plus 2a plus b equal to 0. Now it is a quadratic function in terms of m. And when we have quadratic function in terms of, for example, something like x, it is x squared plus bx plus c equal to 0. Then the roots equal to negative b plus minus square root of b squared minus 4ac all over 2a. So these are the roots. Now suppose we have, for example, two roots m1 and m2. So it says we should have exactly one other answer except 2. So we have two cases. Case 1, m1 equal to m2, and they shouldn't be equal to 2 because we should have a unique answer except 2. Case 2 is m1 is not equal to m2, but one of them should be 2. For example, m2 is 2. Because we shouldn't have two different answers except 2. So one of them 2, one of them is one answer except 2. Now let's consider. When m1 equal to m2, here we call in quadratic equation discriminant or delta b squared minus 4ac. When our answers, our roots are same, delta should be 0. Because if delta is not 0, plus minus square root of delta, we reach two different answers. So here delta or discriminant should be 0 because the answers are equal. And also, if we want to find m1 equal m2 equal to negative b, it will be negative 2a plus 4 all over, if we use this formula here, negative b over 2. So it will be negative a minus 2. This one shouldn't be 2. So the first condition, so we have one first condition, second condition. From second condition, we concluded that a is not negative 4. Okay, so it is the first thing. We reached from second one. Now delta or d equal to 0. So 2 plus a squared minus 4 times a times c, which is 4 plus 2a plus b, should be 0. This is discriminant from 1. Okay, so let's call this one also 3, this condition that we've reached. So in this case, you say, okay, 2 plus a. So if we calculate, it is 4 plus a squared plus 4a minus 16 minus 8a minus 4b equal to 0. So in next step, we say, okay, a squared minus 8a plus 4a is minus 4a equal to 4b minus 16 plus 4 minus 12. It is plus 12. Now, on left side, we can say a minus 2 squared. We have 4 more, so we should add 4 also to right hand side because 2 squared is 4. It will be 16. And then we understand here that a should be even. Okay? A should be even, and let's see a can be what numbers. And here, because we know a, b, c are at least from negative 20 to 20, we know it is at least 0. So this one can be from, for example, b, negative 1, negative 2. It's okay. So this one can be from 0. Let's consider the upper bound. For 20, 80 plus 16, 96. Okay. So here we say a can be 0. A should be even because right side is even. So this part should be even. Plus minus 2, both of them. Okay. And we know a shouldn't be 4 from 3. So a is 4, negative 4 is not possible, plus minus 6 is good because negative 6 minus 2, negative 8. Negative 8 squared is 64, plus minus 8. Minus 8 is not good because minus 8 minus 2 minus 10 squared, 100. So plus 8 is good. Plus 10 is also good. Plus 12 is not good. So how many answers we found? 1, 2, 3, 4, 5, 6, 7, 8. So we found 8 answers here. Now let's check case 2. Case 2, m1 is not equal to m2 and m2 is 2. So one answer is 2 here, so we can replace 2 here. It will be 4 plus 2, we replace m with 2. because M2 is 2. 2 plus A plus 4 plus 2A plus B equal to 0. Okay. So 4 plus 4 plus 4, 12, plus 2A plus 2A is 4A plus B equal to 0. And here, let me tell you one thing here. When x is this, sum of the roots equal to negative B plus minus will be cancelled. It will be negative B over A. Okay, so we have one thing, this M1 plus M2 is, if we use this, negative B is negative 2 plus A over coefficient of this over 1. And we know M2 is 2, so it will be M1 plus 2. So we conclude what? We conclude that because M1 is not 2, we said M1 is not 2, so the sum is not 4. Okay, let me write it here. So negative 2 minus A is not 4. So A is not negative 6. Okay, so it is the fourth rule we've reached here in case number 2. And also we know 12 for A plus B is 12 plus 4A plus B is 0. So we can conclude B equal to negative 4A minus 12. Now, we know B is what? From negative 20 to 20. So the largest A we can say is, let me tell you, 2. It will be the largest A, I mean only A. If A is 3, then this part will be less than negative 20. 2 is okay, 1 is okay, 0 is okay. Negative 1, okay. Negative 2, negative 3. We should pay attention. It shouldn't be negative 6. Negative 3. So we want to see up to what number is 20. It can be 32. Up to negative 8. Minus 20 is minus 12 is 20. So negative 4, negative 5, negative 6 is not possible because of 4, 1. Negative 7, negative 8. If you place negative 8 here, it will be 32 minus 12, 20. If you place negative 9, this part will be greater than 20. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So here also we found 10 cases. So for A and B, we've reached 8 plus 10, 18 cases. And C has no effect. It can be from negative 20 to 20 by assumption of problem. So it will be 20, 41. Okay. So it is 18 times 41. If you multiply 41 by 18, it will be 18. 4 times 18, 72. So it will be 837. So the answer of this problem is 738. Okay. So in quadratic equation, it's important sum of the rules. Let me tell you important thing here. Sum of the roots, product of roots, difference of roots. These things are important. Sometimes difference of roots. Sometimes you should draw the graph. It helps you. Finding minimum maximum vertex is important. Minimum maximum. And vertex is important. Sometimes there are also some other things. For example, look, we know that there is a line and there is a point. That some of the points on this parabola is equal if you consider. If you want to find this point is what, this line is what. We need this in other AMC problems. If you want to learn these things, as I said before, feel free to send message to my WhatsApp number in the description and comments. Okay, so there are lots of quadratic equations, so much useful. Vieta's formulas and Newton's sum, a lot of things that in AMC AIME useful. Okay. AIME I 2023 problem number 10. There exists a unique positive integer a for which the sum u sigma from n1 to 2023 floor or GIF or integer part of n squared minus na all over 5 is an integer strictly between -1000 and 1000. For that unique a, find a plus u. Note that GIF, greatest integer function, or floor denotes the greatest integer that is less than or equal to x. Okay, so let's solve. Means, for example, 2.6, floor of that is 2, but -2.6 is -3. Because -2.6 is between -3 and -2, and by the definition it says it is -3. Okay, now because it says it's important, it says there is a unique, so if you find one a that satisfies this, it is our only answer. This is help, we can say, in the problem. And it says it is between -1000 to 1000. So we understand that u, the absolute value of u, if we can minimize that, it will be good. Now, here, our problem or our challenging part is that we have integer part. So we can't calculate this part, some of these things directly, but we can do something. What we can do? We can say, okay, we know that, for example, integer part of x equal to x minus fractional part of x. Okay, we use this. We say, okay, when you say GIF of n squared minus na over 5, it is n squared minus na over 5 minus n squared minus na over 5 fractional part. It means that, for example, the remainder, for example, look, if you have 28 over 5, GIF of this, it's 28 over 5 minus what? 3 over 5. Because we know 20 over 5 is 5 point something. The reason is what? Because it is 25 plus 3 over 5. It is 5 point something. For example, 5.6. 0.6 after point is because of the remainder. So this part, n squared minus a, the fractional part over 5, is the remainder of this number when divided by 5. So we say consider the remainder. Let's consider mod 5. If n is a 1, it will be what? The first n, we start from 1. It will be 1 minus a. Then for 2, it will be n squared minus na. The remainder we are considering 4 minus 2a. The next one is 9, 3 squared minus 3a. The next one is 16 minus 4a. The next one, 25 minus 5a, 0. So the remainders are these numbers. And then it will be repeated. Because if you add n by 5, mod 5, they are equal. Look, if you add, for example, for 6 and 1, it will be the same. Because look, n plus 5 squared minus n plus 5a. If you consider mod 5, it will be n squared minus na. So if you consider from, for example, from n is 1, 2, 3, 4, 5. These parts are what remainder of, let me move it here. It is our n. All these things are remainder of n squared minus na mod 5. Okay? So here we will see it will be repeated 5 by 5. And instead of 9 minus, okay, so let's do something. Let's do something. So I say we have different values of a. And we want to see what remainders do we have. For example, if a is 1, then this part will be 1 minus 1, 0, 4 minus 2, 2, we want to consider the remainder. 9 minus 3, 6, which is 1 mod 5, the remainder. 16 minus 4 is 12, which is 2, and 0. If a is 2, the remainders will be what? Negative 1, which will be 4. 4 minus 4, 0. 9 minus 6, 3. 16 minus 8, which will be 8, 3, 0. Mod 3, 1 minus 3 minus 2, 5 minus 2, 3. 4 minus 6, negative 2. Negative 2 will be 3. 9 minus 9, 0. 16 minus 12, which will be 2 and 0. A is 4. You can't say 1 minus 4 is what? 1 minus 4 is negative 3, which will be 2. 4 minus 8, negative 4 will be 1. 9 minus 12 will be negative 3, which will be 2. 16 minus 16, 0 and 0. If A, the last part, is 0 mod 5, so it will be 1, it will be 4, 9 will be 4, 16 will be 1 and 0. Okay? So we consider these 5 parts, and if you consider some of them, it is 0. Let me do something first. It is sigma. Let me copy this part. Okay, let's paste it here. Okay. So you can say it is sigma n equal to 1 to 2023, these parts minus na over 5 minus sigma n equal to 1, 2023 fractional part n squared minus na all over 5. Okay, so now for solving this, you should know, look, there are 6 important identities you should know. One of them is 1 to n. I think most of you know 1 to n equal to n times n plus 1 all over 2. One part is 1 squared, 2 squared to n squared, which is n times n plus 1. We need these two identities, 2n plus 1 over 6. One part is 1 cubed plus 2 cubed plus n cubed, which will be n times n plus 1 over 2 all over all squared. And we have around 3-4 more identities. For example, hockey stick, you should know Van der Monde's identity usefully in AIME. And 1 plus r squared to r to the n. We have around 3 or 4 more identities. If you want to learn them completely, feel free to send a message to my WhatsApp number in the description comments. Okay, so let's calculate this part first. We can say the first one is 1 over 5 n squared is 1 squared 2 squared to the first part to 2023 squared minus a 1 plus 2 plus to 2023 minus this part. So we know from 1 to 5 it will be repeated. So if we consider 1 to 5, we can say, okay, for example, this sigma n from 1 only to 5, n squared minus na to 5. For 6 to 10, it will be repeated. So we can consider 2023 up to 2020 over 5. All of them from 1 to 5, from 6 to 10, it will be this. It will be repeated. Why? Because here we said, because, for example, look, n1 to 5 is this. Again, it will be repeated. Here we said, if you change n to n plus 5, the remainders are equal. And here it is the remainder over 5, because it is fractional. And what numbers are left? Sigma 2021 to 2023 n squared minus na over 5. Okay. So look, let's see what parts are more important. Let me open a new page. If I want to see what parts are important, this part is not. We want to find a unique a. There exists a unique a that it is between negative 1000 and 1000. This part is not so much important because we have 3 fractional parts. It is at most 3, and minus that is at least negative 3. Greater than negative 3. So we focus on this part and we want to find an a that minimizes this, and then at the end we will check also this part, that does it satisfy or not. Now I say let's select an a that this part be 0, then we want to calculate this part c. Is it between negative 1000 or 1000? If it was not, we can change a little a and see for what a we satisfy this. So here, if we use these two formulas, it is 1 over 5, 2023 times n plus 1, 2024, times 2n plus 1, which is 47, all over 6 minus 8 times 2023 times 2024 all over 2 minus. And we can copy exactly this part because we want to write it again same time. Or let's do something. Here, let's consider this one as, for example, t. 2020 over 5 is what? 404t minus sigma n equal to 2021, 3 terms to 2023, fractional part of n squared minus na over 5, fractional. Okay. Now here, we want to find an a that make this part 0. So if we factor from 2023 times 2024 over 2, so it will be 47 over 3 minus a. So this part, 4047 over 3 is what? Is 1, 10, 3, 14, 4, 27, 9. This part. So let's consider this. If a equal to 1349, so we understand that a mod 5 is what? Is 4. Because I want to calculate what? I want to calculate a mod 5 is 4. And here we've calculated that in each part the remainders are 2 over 5, 1 over 5, 2 over 5, 0 over 5, 0 over 5. So t will be what? This t here will be fractional part of 2 over 5. So it will be 2 over 5. Okay, so this part. So it will be 2 over 5 plus 1 over 5 plus 2 over 5 plus 0 over 5 plus 0 over 5, which will be what? 5 over 5, which is 1. Okay, so here, if a is this, we consider u equal to negative 404 times t is 1 minus sigma n equal to 2021 to 2023 fractional part n squared minus na over 5. Okay, we will see this part is at most 3, this part is negative 404. So this a works because the problem says a is unique. Now let's calculate u. Because we know it's 2021, 2, 3, there are 1, 2, 3 mod 5. And we calculate if a is 5 mod 4, the first 3 terms, 2 over 5, 1 over 5, 2 over 5. So this part will be 2 over 5 plus 1 over 5 plus 2 over 5, which will be 1. So it will be negative 404 minus 1, which will be negative 405. And the problem wants what? The problem says a plus u is what? So let's calculate a plus u is what? A is 1349. U is what? Negative 405. Okay. So if we subtract 9 minus 5 is 4. 4 minus 0 is 4. 13 minus 4 is 9. So we've concluded our answer is 944. Let's just review this. Look, at first I said if we have this, it is itself minus fractional part. Fractional part relates to remainder of this number. We said, okay, if you add n by 5, the remainder will be same. So we need to only consider 1 to 5, then the remainders will be repeated. For 1 to 5, we calculated for different a's, and we said, okay, 1 minus a, 4 minus 2a, and it is only related to remainder of a when divided by 5. We found all 5 cases, and then I said, okay, u equal to this. Sigma, look, I didn't want to only solve the problem. So because I could, for example, find here a, and then I only use this. I wanted to analyze different aspects of this problem to get ready for future problems and harder problems. Okay, so here I said we can calculate this minus the remainder over 5. Then I said, okay, I can calculate this part. And because I know 1 to 5, I said, okay, 1 to 5, 1 to 5, I consider on up to 2020, then 2021 to 2023 we can calculate. And this is a little number because remainders over 5, it will be each part is at most 1, less than 1, so it is at less than 3. And then we can calculate this part, and I said I consider it is t, so we have 404 t because 1 to 5, 6 to 10, 11 to 15, all these things, and I've calculated this part. Then I said, okay, let's find for some a that it will be 0. Then I want to calculate this. If it was between negative 1000 to 1000, it is our answer because the problem says there is a unique a. If it was not, we can, for example, we can find a approximately, then we can find answer quickly. So here we've considered it is 0. We found that a should be 1349. And because it was 1349 minus a. So if a is 1349, this part is 0. We should focus on this. If a is 1349, then a mod 5 is 4. And this part, the remainders 2 over 5, 2 over 5, our t will be 1. T was what? T was from 1 to 5, the remainders over 5 fractional part. So we replace t with 1. This part was 0, this part was negative 404 minus this sigma, which this sigma when a is 5 mod 4 is this over 5, this over 5, this over 5, 2 over 5, 1 over 5, plus 2 over 5 is 1, so negative 404 minus 1, negative 405. So a plus u is 1349 minus 405, and it is 944. There are lots of other ideas in fractional part. For example, let me tell you one useful and so much important idea. When you are working with fractional part for each x, you say k plus r, which k is integer part and r is fractional part, and work on with k and r. We can solve many problems of AIME related to GIF, divide the problem into fractional part and integer part and solve this. If you want to solve other AIME problems that can be solved with this idea, as I said before, feel free to send message to my WhatsApp number in the description comments. AIME I 2023 problem number 11. Find the number of subsets of 1 to 10 that contain exactly one pair of consecutive integers. Examples of such subsets are 1, 2, 5 and 1, 3, 6, 5, 10. Why? Because here we have only these consecutive numbers, here this. So first, you say, suppose the consecutive numbers is 1 to 2, 1 and 2. Then we shouldn't have 3. And from 4, 5, 6, 7, 8, 9, 10, we should select some non-adjacent elements, okay? Again, if we consider, for example, 2, 3, we can select 1, we can select 4, and from 5, 6, 7, 8, 9, 10, I should select some elements that are not adjacent. In next part, for example, if you consider our consecutive numbers are 3 and 4, 2, 5, we shouldn't select 2, 5, and here from 1 and from 6 to 10, we should select some numbers that are not adjacent. So as you can see, we should find out if we have some consecutive numbers, how we can select some of them that are not consecutive. Okay, so let's define it as, for example, an. It is 1, 2, 3 to n. In how an is what? An, let me tell you the definition. It's in how many ways can we select non-adjacent elements. Adjacent means consecutive numbers. Non-adjacent elements. Okay. So we have an important rule in recursive sequence that when we should see n represents what? This question is so much important. We can solve also IMO problem with only this question, know how to apply it. N represents number of elements, consider first or last of that. Okay, so now N represents the number of elements we consider. If we have N, so we should select 1, 2, 3, the other elements from N minus 2, N minus 1, and N. So we have N, we don't have N minus 1, we should select from here. If we don't have N, if we don't select N, it will be 1, 2, 3, 2, N minus 2, N minus 1, and N. Okay. In this case, that we select N, we can select N minus 1, we select from 1 to N minus 2, it will be AN minus 2. If we don't select N, we should select from 1 to N minus 1. So it will be AN minus 1. Now, we can conclude AN equal to AN minus 1 plus AN minus 2. Okay, so N here we can say at least 2. So A1, A2, A1, we should calculate A1, A2 separately. A1, you say we have 1 or null set. We have 2 cases for A2. When we have 1, 2, we select 1, 2, or null set. You can't select both 1 and 2 because they are adjacent. Please. And always when you see when you say a recursive sequence, try to check at least one more for yourself to make sure. A3, and try to solve it with different way from the way you've solved for recursive sequence. For example, I say if you have the number of elements is 0, 1, or 2. If you have 0 element, it is one case. If it's 1 element, it's 3 case. If it's 2 element, it will be one case. 1 plus 3, 4 plus 1, 5. Okay, so A3 is 5, and we say, okay, 2 plus 3, 5. It works. It satisfies our equation. Okay. Now, here, let's solve. This part will be A8. A7, because 4, 5, 6, 7, 8, 9, 10. A7. This one 1, 2, 3, 4, 5, 6, A6. This part will be A5 times A1. The next one, for example, 1, 2, 3, 4, 5. We want to select 4, 5. So we can select 3, we can select 6, 7, 8, 9, 10. And this part will be A4. This part will be A2. Okay. And the next part, after some part, it will be symmetric. Let me explain for you. For example, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So, for example, if you select 5, 6, we can select this, we can select this. And this part will be A3. This part will be A3. Now, if you select 6, 7, it will be exactly similar to this. Why? Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this one, 6, 7, and it will be A2, A4. Okay, so multiply by 2. So we should multiply these cases, this one by 2, this one by 2, this one by 2, this one by 2, and this one by 1 because it doesn't have any similar case. So if we calculate 2a7, 2a6, 2a1 times a5, 2a2 times a4, a3 squared. Okay, so let's write. Let me write with green. 2a7 plus a6 plus a5 times a1 plus a4 times a2 plus a3 squared. Okay, so now we should calculate from A1 to A7. We use this rule, and A1 2, A2 3. So it's 2, 3, some of them 5, 5 plus 3, 8, 8 plus 5, 13, 13 plus 8, 21, 34. So let's take A1, 2, 3, 4, 5, 6, 7. It is A7. So A7 is 34. A6 is 21. A5 is 13. A1 is 2. So A6, A5, it is A4 is 8, A2 is 3, A3 is 5. Okay, so let's add these numbers. 3 plus 8, 11. 11 plus 2, 13. 13 plus 13, 26. 26 plus 34, 60. 60 plus 21, 81. It will be 2 times 81 plus 5 squared. Oh, sorry, I should multiply this part. Let me rewrite it again. 3 times 8, 24. 2 times 13, 26. Okay. 24 plus 26, it's 50. 34 plus 21 is 55. 2 times 55 plus 50, 105. Plus this part, 5 squared. So it will be 210 plus 5 squared, 25. 235. Okay, so it is our answer. And there is also an IMO problem we can solve with only the idea I told you here, and represents what? Consider first or last of that. Two IMO problems, one of them with this idea and another idea, one of them with exactly this idea. If you want to know the IMO problem that you can solve with this idea and also other important problems, feel free to send message to my WhatsApp number in the description and comments. AIME I 2023, problem 12, let triangle ABC be an equilateral triangle with side length 55. Points D, E, and F lie on BC, CA, and AB respectively. Let me show. Okay, D, E, F on BC, AC, and AB respectively. BD is 7, this length is 7, CE is let me write. BD is 7, CE is 30, AF is 40. Point P inside triangle ABC has a property that AEP, so it is this AEP alpha, BFB this alpha, PCDP this alpha are equal. It says find tangent squared AEP, so it means that we should find tangent squared alpha is what? Before solving the problem, I should tell you an important lemma in equilateral triangle, a famous problem. The famous problem is what? Let me write it here. We call it lemma 1. In triangle, or let me tell you, in equilateral triangle ABC, for example, Q is an arbitrary point, or because here we have P, this P is not that, so let's say Q. Q is an arbitrary point. Point inside the triangle. The triangle. Then prove that. So here we have a triangle. Let me consider for some length 150, 150, and 150. Okay. So it is A, it is B, it is C. So it is a point. For example, we consider the sport. Let's consider because we have 150. Okay. The next one is 30. And this one. Okay, so Q is this point, and we call this one, for example, X. We consider this one Y. We consider this one Z. Prove that part A. Qx plus Qy plus Qz equal to height of the triangle. For example, we call it H. Okay, it is equilateral triangle. All heights are equal. Part B, bx, if we consider alternative sides, bx plus cy plus az equal the sum of other three sides, three lengths. Bx plus cy plus az equal to cx plus AY plus BZ. Okay. Now let's prove first part A. We can prove part A with two ways. One way is to draw this one and then prove that QZ equal to this, then draw, for example, this altitude and prove. Try to prove with this way as solution number two. Let me tell you an easier one to understand. So look, we calculate area of ABC with two ways. We know that h times, for example, suppose the length is A over 2 is area of ABC. Height times the base. Or you can say it is equal to sum of three triangle QBC plus area of QAC plus area of QAB. QBC equal to QX times A over 2. QAC equal to QY times A over 2. Plus QAB equal to QZ times A over 2. Now here you say, okay, h times A over 2 equal to, you can factor here from A over 2. A over 2 times QX plus QY plus QZ. Okay, we cancel A, we cancel 2, so QX plus QY plus QZ equal to H. It's solution number one for this. Solution number two, let me explain for you another solution. So let me open a new page. So in solution number two, I draw a parallel line to BC. Then I draw altitude here, height. So for example, suppose we call it A, for example, T, we call this one L. We want to prove solution number two. We want to prove yqx plus qy plus qz equal to h. H is what is AT, which is AL plus LT. LT, because it is rectangle, we can say AT, LT equal to QX. We can cancel. So now we should prove QY plus QZ equal to AL. Okay. So now that we want to prove this, let me tell you we do what. Here, let's copy from this shape. In this new shape, I erase, let me answer this one. I erase all these parts. We don't need them anymore. Okay. This part. Okay, now it's easier. Why? Q is an arbitrary point with, here we call it, for example, B prime, C prime. Q is an arbitrary point on B prime, C prime. We want to prove y, qy here we want to prove. YQY plus QZ equal to AL, which is altitude of this triangle. It is more specific. It's a special case of previous one by this thing we've done by erasing this part. Now again, I want to do another thing. I draw and from Q, I draw a parallel line to this part, and here we know AL equal to, let me draw with this. I know AL equal to, for example, B prime K. Okay. Equal to B prime K, so we don't need AL. So I erase this part, I erase this part, I erase this part. No. Because it is perpendicular and instead we draw parallel, this one is also perpendicular, this one perpendicular. Now QY is, for example, let me call this point W. B prime K is equal to B prime W plus WK. We know WK because rectangle equal to QY. So we should prove YQZ equal to B prime W. Okay. So here we know if I consider, for example, it is equal to For example, MB prime Q, because they are parallel line to A prime C. MB prime Q is an equilateral triangle. So QZ and B prime W are two heights of this triangle. So they are equal, this is equal, this is equal, so it is equal. So we've solved this problem with two solutions. It has also another solution. Now we want to prove part B, why bx plus cy plus az equal to cx plus ay plus bz. And after proving these two things, we can prove the problem easily. Okay, so here Q is inside triangle, like the solution of previous part. We've considered Q is on one side, then solved. Here, at first, I solve it for a special case. I say, okay, suppose, for example, we have an equilateral triangle. So 90, this one, and this one. We call it, for example, A. Here, for example, B prime, C prime. I want to consider this one. And we consider Q. Then, if I draw heights, this one, it is Y, it is Z, it is this, it is this, it's C prime. Then I want to prove same thing. If we consider alternate sides, lengths, this equal to the other. So let's prove it. I want to prove that YQB prime plus C prime Y plus AZ, Y is equal to QC prime plus AY plus B prime Z. Okay, so if I want to prove this, I know because it is, let me minimize this. I know it is 60, so it is 30. And this one is 30, this one is 60. So we can say what? We can say if, for example, it's QC prime is, if this one is T because it is 30 and it is right angle triangle, the hypotenuse is twice this size. And the other one, for example, we call this one R because it is opposite to 30, it is 2R. Now, suppose the length of all sides equal to L. Okay, so QB prime is 2R, QC prime Y is T, AZ is L minus R, QC prime is 2T, AY is L minus T, B prime Z is R. Now, we cancel L from both sides. The left hand side is T plus R, Y is equal. Right hand side also will be T plus R. So equal, equal. Now here, why it's useful? Let me erase this part. If here we draw this part, then we can say we call it, for example, we want to prove what? We want to prove T plus W plus Z. W plus Z equal to CX A minus T, A minus 3A minus T minus W minus Z. So we want to prove this. Or let's not use TWZ here. Oh, sorry, this T is not equal to this T, so let's erase all these things that we have. And consider new things. Okay. So here we call it C prime, here we call it B prime. Bx, we want to prove this. Bx is what? Bx, we write Bx exactly. Cy is what? Is Cc prime plus C prime y. Let me move it to the left side. Okay. Az is what? Is Az equal to Cx plus Ay plus Ay plus Bz. So we can say Bz equal to Bb prime plus B prime Z. Okay. Now, if I draw this part, because I want to say BQ CC prime. I can say, if I consider b double prime, c double prime, I can say cx equal to this part plus this part. This part equals to c prime cube. C prime cube plus c double prime. Okay, so instead of cx, I write it, let me erase, c double prime plus, instead of c prime x, I write c prime cube. C prime cube. And instead of bx, I write bb double prime plus this part, which is b prime cube. Okay. So instead of bx, I write bb double prime plus b prime cube. Okay. Now we know what? We know that by this part. B prime cube plus c prime y plus az. Let's show it. B prime cube plus c prime y plus az equal to the rest qc prime plus ay plus b prime z. They are equal. So we can cancel all these things. So it is equivalent that we prove bb double prime plus cc prime y, it is equal to cc double prime plus bb prime. Now, we know it is 60. This angle is 30. So cc prime is 2cc double prime. Is 2cc double prime. And this one also is 30. So bb prime equal to 2bb double prime. Okay, so we can cancel one cc double prime here, one bb double prime here. So it is equivalent that we prove cc double prime y is equal to bb double prime. Okay, the reason these two things are equal is these two triangles are congruent. Why? Because we draw altitudes here and this line is parallel to this. It is 60, these two triangles, the angles are equal. Also, these sides are equal. So the corresponding lengths are equal because, as I said, BB prime B double prime is congruent to CC prime, triangle CC prime C double prime. Okay, and we can prove this. Okay, so we proved both parts A and B. Now let's solve the problem. Here, because it says tangent alpha, we should draw three perpendiculars. The first perpendicular is this. The second one is this. The third one is this. And we can say, okay, let's try it with green. We call this one X. We call this one Y. We call this one Z. We know tangent alpha. We have three triangles that contain alpha. Tangent alpha equal here in triangle PXD equal to opposite over adjacent. PX over DX. It is equal here to PY over YE. And here it is equal to ZF over PZ. Let's see. ZF over PZ. PE over YE. Oh, sorry, I said PY. Yes, PY. Oh, sorry. Yeah. Let me correct this part again. Look, opposite over adjacent. PX over DX, it's okay. PY over YE, it's okay. The last one, PZ over ZF, okay. And we have an important rule in algebra if AB, for example, equals CD equal, for example, or let me write. If A1 over B1 equal to A2 over B2 equal to AK over BK, you can say it is equal to sum of the numerators, A1, A2 to AK over, all over, B1 plus B2 to BK, okay? And the proof is not hard. You can say, for example, it is considered is T, then all AI is equal to BIT. So we can replace A1 to AK with B1 to B2 T to BKT, and the ratio is T again. So we can say is equal to PX. By lemma 1, we know sum of the numerator is what sum of denominator. We can calculate dx plus y plus z. Sum of numerator px plus py plus pz is equal to height by lemma 1. That we proved. Dx plus, let's consider dx y is at f. So we've proved by lemma 1 that the alternating sides bx, ay, and sorry, bx, cy, az equal to other sides. So bx plus cy plus az equal to xc plus ya plus, sorry, here is bz. bx, cy, why here I said this, af. Okay, so az we should consider. Now let's check, make sure to see it's correct. Cx, ay, and the last part bz. Okay, so we've considered and we've reached they are equal. Bx is what? Is 7 plus dx. Cy is what? Is 30 because the problem from assumption of problem is 7 is 30. So next one is 30. Cy plus ey. Az is 40 plus zf equal to xc plus ya plus bz, which is, we know, sum of all of them, sum of this one as this one equal to 3 sides. So 3 sides equal to what? 3 times 55. The problem says the length of the equilateral triangle is 55 here. So it will be 3 times 55 over 2. So it's 165 over 2. So we can replace here, we can say 165 over 2. Now, we've concluded that we want to calculate the denominator here. Dx plus ey plus zf, dx plus ey plus zf equal to 165 over 2. 30 plus 40, 70 plus 777 minus 77. And it will be 2, 165 minus 154. And it will be 11 over 2. Okay? So this one will be 11 over 2. H is what? We can use Pythagorean theorem here. If you draw, it is 60. So it is 55 root 3 over 2. It is the formula in equilateral triangle. Because sine of 60 is root 3 over 2. You should memorize it. 2, 2 will be cancelled. 11, 55 will be cancelled. 5 root 3. So tangent alpha is 5 root 3. So tangent squared alpha is 5 root 3 squared. 5 times 5, 25 root 3 squared is 3. So the answer is 75. Okay. So tangent squared alpha equal to 75. Okay, if you want to learn other important things in equilateral triangle, and as I said before, there are 40, 50 important formulas in geometry and other topics, you should memorize if you want to learn them. Send message to my WhatsApp number in the description and comments. AIME I 2023, problem number 13. Each face of two non-congruent parallelepipeds is a rhombus whose diagonals have lengths root 21 and root 31. The ratio of the volume of the larger of the two polyhedra to the volume of the smaller is m over n, where m and n are relatively prime positive integers. Find m plus n. A parallelepiped is a solid with 6 parallelogram faces, such as the one shown below here. It is more specific. Instead of parallelogram for the faces, it's rhombus. Okay, at first let me tell you the volume is what. If you draw, for example, the height here like this, if we call it h, perpendicular, and for example this part is ABCD, the volume equal to h times area of ABCD over 2. Sorry, h times area of ABCD. And it says find the ratio of the volume. So we should consider the two cases that we have, and we should find H1 over H2 is what, because V1 over V2 for both of them. The base is ABCD, so we should find the ratio of the heights equal to what? Equal to m over n, and we should find m plus n. Okay, now a hard problem is what happens, for example, H1, H2, that in what case, because it is 3D and a little imagination is hard, we consider for both cases ABCD here, it doesn't change, and the diagonal AC is root 31, the greater one, BD is smaller one, is root 21. And then we say, okay, it is ABCD, we call it EF. This part is important, that AFEB, AE is the larger diagonal, or A or BF. So in case 1, we consider AE is root 31, this diagonal, BF is root 21. And in case number 2, we consider AE is the smaller one, root 21, and BF is root 31. Okay, so let's consider first case. Is easier to imagine because the figure is exactly this. So we want to find, for example, we call for this one H1, for this one H2. So we want to focus on finding H1. Okay, so let's draw the altitude. If I draw this one, if I draw this one, the altitude by symmetry is here. We want to find this one. For example, let's call this one H. So we know FH squared. Let's also draw this part. We consider this center, for example, as GHJK, for example, is a good name. Let's call this one K. And we say what? We say, okay, we say FH squared. We want to find FH. H1 equal to FH. Okay. So H1 squared here by Pythagorean theorem in triangle AFH equal to AF squared. And let's find length of AF. Length of all of them is rhombus. So, for example, for both cases, we know all of them AB also equal to L. AB squared, which is L squared, equal to, we know this angle is 90, equal to BK or BK squared plus AK squared. BK is what? BD is root 21, so BK is root 21 over 2 squared. AK is what? Is root 31 over 2 squared. So we conclude that L squared is 21 over 4 plus 31 over 4, which will be 53 over 4, which is 13. So L equal to root 13. So H1 squared is, which we know is FH squared. By Pythagorean theorem, we can say it is equal to AF squared, which is L squared minus FH squared. Now, here I want to calculate FH with using another right angle triangle and using another Pythagorean theorem. Okay, so if we connect this to this part, this to this part, it will be FH squared equal to FB squared minus BH squared. Okay. It is in triangle what? In triangle FBH. The previous Pythagorean theorem, H1 squared, was in triangle AFH. Now we want to use another Pythagorean theorem. We say, okay, we have FB squared minus BH squared is what? BH squared, if we consider this triangle, it is 90 this angle. So in triangle BKH. In triangle BKH, instead of BH squared, we write what? We write BK squared plus KH squared. Plus KH squared. Okay, now let's see what lengths do we have. AF squared we have is L squared, which is 13, minus, oh, sorry, here. FH squared is AF squared minus AH squared, okay? So 13 minus AH squared equal to this. FB squared, FB is what? Is root, it is the smallest. We said FB is root 21, so FB squared is 21 minus BK squared. We know this length is root 21, so, and this is root 31. Root 20, if we consider BD is the smaller one in all cases, here we said. So BK is half of that, so it is root 21 over 2 squared plus KH squared, okay? And instead of KH, because I have AH here, I can say instead of KH, I write AK minus AH squared, okay? So let's simplify. 13 minus AH squared equal to 21 minus root 21 squared is 21 over 2 squared is 4. AK is what? AK is half of AC. AC is root 31, so it's root 31 over 2. Root 31 over 2 minus AH squared. Okay. Now, we multiply both sides by 4. So it will be 52 minus 4AH squared equal to 84 minus 21 plus, because 4, if we take 4 inside this, and we have a square here, so it will be 2. It will be root 31 minus 2AH squared, and sorry, because we have minus minus, we should change it to minus. And now let's calculate. It will be 52 minus 4AH squared equal to 84 minus 21 is 63 minus 31, the first one squared, minus the next one squared, 4AH squared. Plus minus minus will be plus 4 root 31 AH. Okay, now negative 4AH squared, negative 4AH squared will be cancelled. 63 minus 62, 32. 52 minus 32 is 20. 20 equal to 4 root 31 AH. And then we divide both sides by 4 root 31. So AH equal to 20 over 4 is 5. 5 over root 31. And we found AH. Now we can calculate easily H1 that we wanted, because H1 is AF squared, so let's write H1 is AF squared, which is L squared, which is 13, minus AH squared, it is A1 squared, minus AH squared. AH squared is what? 25 over 31. Okay, so it will be what? It will be 13 times 31 minus 25 all over 31. If we calculate 13 times 31, it will be 9331. It will be 304. So it will be 403 minus 25 over 31, which will be 403 minus 25 is 378 over 31. Okay, so we found H1 is root 378 over 31. Okay. Now we want to consider next case that AC, in this case, H2, let me copy and paste it. Okay, case 2 is this, and again, look, ABCD are same. ABCD is exactly like case 1. The only difference is AE now is a smaller diagonal. Now, if you draw this figure, the diagonal, if you want to consider, for example, F this, you will see, okay, if you want to calculate this part, let me show you, this part will be negative. You understand that the height doesn't come here, but let me select, if you select, for example, from E, Look, if you imagine when AE is a smaller one, this part will come front and AE come near to us, and E, the height will be here, some point here. Okay, so we call this one here, for example, we had H, let's consider, we know it is K. Let's call this one, for example, T. Okay, this height. Or let's call this one H prime to pay attention that it is altitude. Okay. So again, we do the same thing, EH prime squared. So first, we consider triangle BEH prime. Let's write it here. BEH prime. So because it is 90, so BEH prime squared equal to EB squared minus BH prime squared. Okay, and we know the length of rhombus from previous part is root 13, and we know AC is root 31, BD is root 21. The only change is that AE is now smaller diagonal and BF in this phase larger diagonal. Now, EH prime. When you consider this EH prime, we try to create another Pythagorean theorem or another right angle triangle to apply Pythagorean theorem. EH prime squared is equal to, again we use triangle EAH prime equal to EA squared minus AH prime squared. So we write EA squared for AH prime squared. We use another Pythagorean theorem in triangle AKH prime. AH prime squared is AK squared plus KH prime squared. Okay, so it will be this part. So let's replace. EB squared is L squared, which is 13 minus BH prime squared. BH prime, we write itself. BH prime squared equal to EA squared. EA squared is smaller diagonal is root 21 squared, which is 21 minus AK squared. AK is half of AC, is root 31 over 2 squared. Plus KH prime. KH prime is what? Because we have BH prime, we want to find it. We write KH prime as BH prime minus BK squared. Okay. Now let's simplify. We have 13 minus BH prime squared equal to 21 minus 31 over 4 plus BH prime minus BK. BK, we know BK is what? Because BD is root 21 minus root 21 over 2 whole squared. Okay? Now, I'm sorry, because we have minus plus, it will be minus. So first we multiply both sides by 4. It will be 52 minus 4BH prime squared equal to 84 minus 31 minus 2BH prime, because if you take 4 inside this bracket that we have square here, it will be 2 minus root 21 whole squared. So let's calculate. 84 minus 31 is 353. 52 minus 53 is negative 1 minus 4BH prime squared. Now let's expand this, negative 4BH prime squared, and it's good because we can cancel from with this. Minus 21 root 21 squared, which will be minus 21, plus negative 2, negative times negative positive, plus 2 times 2, 4, root 21 BH prime. Okay, now here, we can cancel this part. If you take negative 21 to left hand side, it will be 21 minus 120 equal to 4 root 21 BH prime. Okay, now we divide both sides by 4 root 21. So BH prime equal to 20 over 4, 5 over root 21. Okay, so we found BH prime. Okay, because we found BH prime, we wanted to find EH prime. EH prime is H2. Now, H2 squared, which is EH prime squared, equal to EH prime squared. Here we've written is 13 EB squared, 13 minus BH prime squared. And we found that BH prime is 5 over root 21. So let's replace it. 5 over root 21 squared. Okay. So it will be 13 minus 25 over 21. And it will be equal to 13 times 21 minus 25 over all over 20. 13 times 21 is 13, 26 is 273. It's 273 minus 25 over 21. It will be 248 over 21. And we've reached this. So H2 equal to what? H2 equal to root 248 over 21. And we know H1 was what? H1 we've calculated here. Root 378 over root 31. Okay, so let's write these two things, H1 over H2. And now maybe you ask, H1 is greater or H2 is greater? We don't know. We calculate this, it says ratio of the larger one. And we find M over N. And if, for example, it was less than 1, we consider reciprocal of that because our fraction should be greater than 1. H1 over H2. H1 is square root of 378 over 31. And H2 is 248 over 21. Okay. Now we can consider all of them in 1 square root 378 over 31 and consider reciprocal of this 21 over 248. Okay. We can, for example, simplify. We can 2 plus 4, 6, 6 plus 8, 14. It is not multiple of 3. Okay, so let's see what are the things we have. 378, the sum is an 18 multiple of 9, so it will be 9 times. 4 times 9, 36, 18, it's 42. And times 21, 31. Times this part is it's 8 times 31. Okay, 3, 1. Okay, now we can cancel. We can cancel 8 divided by 2 is 4. This divided by 2, 21. Okay, now it's good. Because we have 21 squared, 21. Square root of 9 is 3. Square root of 31 squared is 31. Square root of 4 is 2. So the numerator is 63. The denominator is 62. Okay, we said it should be greater than 1, and we say, okay, H1 is greater than H2 is okay. For example, if we've considered H2 over H1, it was 62 over 63, you should consider reciprocal. But because the problem wants M over N, it was not important because you want to find sum of them. And if we calculate that, it's 63 plus 62, and they don't have any common factor because 21, 3, 7, 3, 31, 2. 1, 2, 5. And it has proof that two consecutive numbers, their GCD always 1. They are relatively prime always, so we can work also on GCD if you wanted. Okay, this problem also you could solve with cross product, dot product. It has another formula. We can work on that. If you want to learn how to solve 3D problems in geometry and also especially in combinatorics, we have so much hard problems. If you want to learn them, as I said before, feel free to send message to my WhatsApp number in the description and comments. And also Pythagorean theorem, double Pythagorean theorem, it means I will explain in my future videos that how to apply double Pythagorean theorem. Okay. AIME I 2023 problem number 14. The following analog clock has two hands that can move independently of each other. Initially, both hands point to the number 12. The clock performs a sequence of hand movements so that on each movement, one of the two hands moves clockwise to the next number on the clock while the other hand does not move. Let n be the number of sequences of 144 hand movements such that during the sequence every possible positioning of the hands appears exactly once, and at the end of the 144 movements the hands have returned to their initial position. Find the remainder when n is divided by 1000. Okay. For solving these types of problem, drawing a good graph is so much useful. Also, this idea is useful in AIMC. Okay, we have 12 cases. So, look, at first we have, for example, the clock, hour, and minutes. We can say, for example, 12 we can consider it as 0. Then we should, at the end, we should reach again 0, 0, but we should see all cases. For example, in next case, you can go to 1, 0, then you should go, for example, you can go to 2, 0, or 1, 1, then you can go to 1, 2, and you should see each case exactly once. How many cases are there? So if you consider, for example, it is H, it is M. H can be from 0 to 11. M can be from 0 to 11. So we have 12 cases for H, 12 cases for M, so 144 cases, and we should reach at the end to initial case, and that's the reason we have 144. So now, because we have two things, hour and minute, H and M, we can draw a two-dimensional table. At first, we are in 0, 0. For example, suppose the horizontal line relates to H, vertical line to M. So for example, it is 0, it is 1, it is 2, it is 3, 2, it is 12, it is 11. And this part, if you consider vertical, it is 0, it is 1, it is 2, it is 3, up to 11. And also these cases. So as you can see, we have 144 cases, exactly this 144. So for example, from this, you can go here or here. All these cases, for example, when you reach this, you can go to this one or this one. When you reach this, you can go, because look, when you reach 11, then you go to 12 again, or 12 is equivalent to 0. You reach this, you can go here to or here. If you consider each vertex the out degree means the output from this. We have two outputs, two inputs in general. So the problem is equivalent. You start from 0, 0, see all the cases, and in each step you can go 1 unit to right, 1 unit to up. If you reach the end, for example, like this, 1 unit to right goes back to 0 again, this part. And you want to see all vertices exactly once and reach to 0, 0 again. Okay, one useful idea that before also AIMC I said is considering small examples. So let's analyze, for example, suppose we have two cases. 1, 2, 0, 1, 0, 1. We want to see all cases. So at first without loss of generality, suppose for example we consider 1 unit to right, and or we can consider 1 unit to up. When we go 1 unit to right, we don't have this anymore. Because look, when we see all things exactly once, so the edges that we draw, the lines that we draw, the directions that we draw, for each vertex, for each point, we should have one input, one output. Because we have one output here, we don't have this anymore. So we know it has one input. From here, it's not possible because it has output to this. So we have this one. And then we can say it has output here, so we can have output here. It's okay, like this. And we don't have this one. So if we want to consider vertical line, from this part we will see it's not possible. Because look, if we want to, for example, if it has this one, then it will be bad. It will be closed inside itself. If we draw this one, then let's see, we have this one, this one, this one. And then here we have this one. Oh, okay, sorry. That's okay. It is one case. If you consider this case, we have this vertex directed to this one, so we don't have this direction anymore. So we should have direction to this one. We know that it has input, so we don't have input from this. And also, if we want to consider, we don't have this because then it will be closed, this one, this one. So we have two cases, okay, when we have 2 points here. But we want to solve for 12, so here is n12. We check for n2, we have two cases. Okay, now let's consider n3. When we have n3, in n2, because it was obvious, we've not get anything useful. In n3, let's consider we have this. Because we have output here, we don't have output in this case, so we have output like this. Because it doesn't have output to this, because we've drawn this, we have one output from each vertex. So we have to this, we don't have to this one, so we have this. So from this edge, we've concluded many other edges. Now, let's consider that we have this edge also or not. So we consider first horizontal line from down. From below here, when we consider, we say, okay, we draw this one. Let's consider all cases. Now, in this case, we can consider if we have only this. So suppose we don't have this, we don't have this. If we draw exactly one of them, and if we draw only this to this, and as you can see, because the problem is symmetric, we can say these three cases are same. Okay, because we have one edge in first row by symmetry. So here, because look, we should find a cycle that passes through all vertices. So the starting point is not necessarily important. So if you have two edges, you can draw like this. And again, all other cases are similar. If we have three edges, so three edges is useless because it will be this. So this one is bad. And we can also calculate, for example, the first one here. So because we don't have these parts, we don't have this, so we don't have this output, we should have this out. Here, we don't have this input, so we should have input from this part. Now, because we have input from here, so we don't have output to this from this vertex, so this one needs input, so you should place this. Now, let's analyze another case. For example, this one has input, this one has this. Okay, we don't have this part, this input, so we need input from here. Let's consider. Now, if I draw this one, then you will see it will be closed, this board, and we don't have a cycle pass through all cases, so it will be this here. And then for this part, we can see that it should connect to this because it can connect to this one not possible, this one is unique, and also this one. Or let me tell you by unique cases, we say, okay, the output here, we cannot select this, so we should select this. And because it has input now, we can't select this, so we have to select this. So also you don't need to pay attention. In a unique way, this cycle is good. Okay, other cases similar. So look, we have three edges, three choose one. And maybe someone asked, what about three choose zero? So let's see which of them is good. Three choose two plus three choose three. 3 choose 3 was bad. 3 choose 1 was good. Here, if you have one edge, let's check 3 choose 2 and 3 choose 0. 3 choose 2 is this one. And, okay. So we have output here. We don't have output to this, so it needs output from here. So you don't have output to this one. So it needs output from here. If you consider this edge. Now here, we don't have output here, so it needs output from this one. We don't have output to this, it needs output from this. Now, here, we know we have two edges here, so we don't have this edge. Because we don't have this edge, it needs input, so it should get input from this port. And because we have input, so the output from here, so we don't have this output, so it needs input, it gets from here. And then it has output to this port. It doesn't have output to this port, it needs output, so from here it will be okay. So 3 choose 2, all cases are okay. Now let's check 3 choose 0. Let me erase one case here and consider 3 choose 0. So we don't have this, we don't have this, we don't have this. So because we don't have this, we need output, so we have this. And it needs input, we should have this. And for this one, we know we don't have this part output, so it should be like this. Similarly, we should have like this. Again, here it doesn't have input output by this part. Horizontally, it should have vertically. Okay. Okay, now this one has input from this part, so we can't draw this because then it has two inputs. So we should draw this. And now look, this cycle is independent from other parts and it is bad. So 3 choose 0 is bad. Now here for 3 we will see for first level 0 edge and 3 edges are bad, 1 and 2 are good. Now in next step we check for 4 and then we find the idea and then we can prove it. So if you have 4, it means 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Again, if you consider first level, if you draw, for example, 0 edge, again, it will be bad. So 4 choose 0 is bad. If you draw one of them, you can see it is good. Why? You can check, let's draw all of, you can't draw them. So because you draw this, it doesn't have input. It has input from here, so you can't draw this. So you have to draw this as input. Because it has input, you can't draw this, so you have to draw this. Because it has input, you can't draw this, so you have to draw this. Now, we don't have this edge, so we don't have this output, so we should draw this out. We have this edge, we don't have this output, so we should draw this output. We don't have this edge, we don't have this output, so we should have this output. Because it has input, so we don't have this input from here. We should have this. We don't have this one, because of this has two inputs. Look at this, we don't have this one. It has two inputs again, so we have this. And okay, here we don't have this because then it has two inputs. We draw this one. Because it has inputs, we can't draw this, so we have to draw this one. We can't draw this because it has input, so we should draw this. And for this one, let's see. For this vertex, we can't draw this output because for this it will be bad. So we should draw this. And then we can't draw this because then it has two inputs, so we have to draw this one. And then we can see that it needs output. We can't draw this output, so we have to draw this output, and it will be good. So we can see 4 choose 1 is good all cases. Now for 2, let's see 2 is good or bad. So if you draw one case, you will see 2 is bad, and we have two cases. They are adjacent or they are like this. Let me draw this one. They are not adjacent, and also you can use same way to say 4 choose 2 are bad. So when you have this, we don't have, let me tell you as an input, we don't have this input for this vertex. So it should be connected to this. Doesn't have this output, so we should have this out for this one. Now here we have this output, so we don't have this output, so we need this output. We have this input, so we don't have this input, so it should show like this. Now let's other cases. We don't have this line, so we don't have this output. We should draw this output. We don't have this one, so we should draw to this part. Now this line. We have this input, we've considered we have this output, so we don't have output to this one, so it's from this one. Now if you consider we don't have this output, we have this. Okay, if you consider this vertex, we don't have this because then it has problems, so we should draw this. So we can't have input here, so we should draw this one. And so we don't have this part because of this vertex, so we should have this. And because we don't have this vertex, it needs input, so we should consider input from here. And then we don't have output to this vertex, so we should have output to this one. And here, this one can't have output to this part because of this. So we should have output to this part. And as you can see, we don't need to draw anymore. Because look, this one, if it starts like this, so we've not seen all vertices and it's bad. And you can prove 4 choose 2 is bad. And then you can guess why, for example, you can see 4 choose 3 is good. Again, 4 choose 4 is bad. So this one good, this one bad, this one bad. So what numbers for 4 are bad? 0, 2, 4. For 3, 0, 3. So we can guess that the numbers that are not relatively prime to n is bad. So the answer is sigma n choose k, where k is from 1 to n, which GCD or HCF of k and n is 1. Okay, because if n is at least 2, you can say k from 1 to n minus 1. N choose k. And then the path will be unique. Okay, it has proof. We can easily prove for general n that we have to prove two things. One thing, why if GCD is 1, the path is unique. Why if GCD is not 1, it is not possible. Okay, so now in this problem, it is n is 12. We found the idea. We can say, okay, the answer is 12 choose 0, 0 no, 12 choose 1, plus 12 choose 2 no, 3 bad, 4 bad, 5, plus 12 choose 6, 12 choose 7, plus 12 choose 8, 9, 10, 11. Okay, and we can see 12 choose 1, 12 choose 11 are equal, 12 choose 5, 12 choose 7 also are equal. So it will be 2 times 12 choose 1 plus 12 choose 5. We want to calculate this. Let's calculate. It will be 12 times 12 plus 12 times 11 times 10 times 9 times 8. All over 5 times 4 times 3 times 2. Okay. 2, 4, 8 we cancel. 3, 3, 9, 3. 5, 2 will be cancelled. Now, if we multiply, it will be 2 times 12. 2 times 12 is 24. Plus 2 times 3, 6. 6 times 12, 72. 72 times 11. Okay. And if you consider 72 times 11, you can write it like this. It will be 792. So it will be 792. And you can say, okay, the answer is 24. Plus 2 times 2, 4. 2 times 9, 18. We have 1. 2 times 7, 14. Plus 1, 15. Okay, if you add these two numbers, 4 plus 4, 8. 2 plus 8, 10. You have 1 plus 5, 6, this. And so the answer is this. But the problem says what? The problem says find the remainder when divided by 1000, the last 3 digits. So the answer will be, last answer is, let's call this one big N. The problem says big N. The answer is 608. Okay. If you had question or want to prove the 2 steps I told you, this strategy is so much useful, especially in full solutions exam like USAMO, IMO, BMO, round 1, round 2, other exams, that you consider a small example, you find the idea, you should generalize that and prove it by induction and other methods. We can solve many problems with this idea. Okay, so if you want to know how to prove this part completely, as I said before, feel free to send message to my WhatsApp number in the description and comments. If you want to learn other ideas. AIME I 2023 problem number 15. Find the largest prime number p less than 1000 for which there exists a complex number z satisfying 3 conditions. The real and imaginary part of z are both integers. Length of z equal to square root of p, and there exists a triangle whose 3 side lengths are p, the real part of z cubed, and the imaginary part of z cubed. Okay, so let's consider z. We write z as a plus bi. From first condition, let's consider first condition, second condition, third condition. From first condition, we conclude a and b are integers. From second condition, Length of z is root a plus root a squared plus root a squared plus b squared equal to root p. So if we raise to the power of 2, a squared plus b squared equal to p. Third condition, it says there exists a triangle whose three sides lengths are p, real part of z cube, imaginary part of z cube. So at first you should say real part of z cube should be greater than 0. Imaginary part of z cube should be greater than 0. We know p is greater than 0 because p is a prime number and it starts with 2. So because the minimum prime number is 2. Now they should be sides of triangle, so triangle inequality should be satisfied means what? P plus real part of z cubed. We should have what? We should have a triangle that the sides are what? For example, P real part of z cubed, imaginary part of z cubed. So P plus real part of z cubed should be greater than imaginary part of z cubed. P plus imaginary part of z cubed is greater than real part of z cubed. And imaginary part of z cubed plus real part of z cubed should be greater than what? Should be greater than p. Okay. At first, I want to say that this inequality is obvious. Why? Because, look, for example, consider z cubed. For example, suppose z cubed is here. It's not important that it is in what quota. So, for example, suppose it is z cubed. Now we know that this triangle. Let me tell you something. Because we said real part of z cube, imaginary part of z cube should be positive, it should be here. So if it is z cubed, we can say in this right angle triangle, it is imaginary part of z cubed. It is real part of z cubed. And this part length is z cubed. Okay. In this triangle, we have triangle inequality. So we know imaginary part of z cubed plus real part of z cubed should be greater than this cubed. Also, it is equal to length of z cubed. Length of z here is what we know from second condition. Length of z is root p. So it is root p cubed, which is root p times root p is p, p times root p. It is greater than p. So as you can see, this condition will be satisfied because we know some of them is greater than p root p, the length of this p root p is greater than p. So this one is satisfied. So we should only focus on this part, and on these two conditions. So let's analyze these things. At first, let's focus on real part of z cubed and imaginary part of z cubed. Z is a plus bi. So z cubed is what? You should know binomial theorem or binomial expansion for general n. If you don't know that or other things we are using in this problem or other problems, as I said before, feel free to send message to my WhatsApp number in the description and comments. If you know that it is a cubed plus 3 times first one squared times second one plus 3 times first one times second one squared plus second one cubed. Okay. And because we know that I squared is -1, so it will be a cubed plus 3a squared bi plus I squared is -1, so it will be -3ab squared. Here, I squared -1, so it will be negative b cubed times I. Okay, because I squared is -1. Now, we can say z cubed. If we consider imaginary part, this and this, it will be a cubed minus 3ab b squared, and real part, imaginary part is this part, 3a squared, b minus b cubed times I. Okay, so let's write the conditions. And we know a squared plus b squared is p. So we will use it after calculation something. We are focusing on this part 3, condition 3. Real part of z cubed is what is, let me write, real part of z cubed should be positive from third condition, which is a cubed minus 3ab squared should be positive. Imaginary part of z cubed, which is this part, 3a squared b minus b cubed is positive. And from here, we conclude if we factor from a squared minus 3b squared is positive. From here, b times 3a squared minus b squared should be positive. And the other thing, because we know that this condition is satisfied, we know these two conditions should be satisfied, these two. So if we copy and paste it here, so here we conclude what? P is greater than imaginary part of z cubed minus real part of z cubed. If we subtract real part of z cubed from both sides, and if here we take, let's, this here and this and right side, this to left side, so imaginary part of z cubed minus real part of z cubed is greater than negative p. So when something is between p and negative p, so it is equivalent that it is absolute value of this is less than p. So imaginary part of z cubed minus real part of z cubed is less than p. Now, if we use these two things, because real part is this, imaginary part is this, if we subtract, imaginary part is 3a squared b minus b cubed minus real part is a cubed plus 3a squared ab squared. This one should be less than p. Now we know p is what? P is a squared plus b squared from this condition. From here, from second condition, it is a squared plus b squared. Now here, we consider these two things and these two things. So, from 3, if we factor from 3ab, it will be a plus b minus a cubed plus b cubed. And we can factorize it. It's famous identity. A plus b times a squared minus ab plus b squared. Okay? So it is less than a squared plus b squared. So if we factor from a plus b, it will be a plus b, 3ab minus this. So 3ab minus this 4ab minus a squared minus b squared is less than a squared plus b squared, because this part is inside absolute value, so you can negate that. Multiply by -1, so it will be a plus b times a squared minus 4ab plus b squared less than a squared plus b squared. So let's write the things we've reached so far. We have two conditions here. Let's consider it is 4, it is 5, it is 6th condition. Okay, so let's rewrite them again. Okay, these are our conditions 4, 5, 6. Okay, now we want to focus on the signs of A and B. So let's consider, let's consider this case. If A is positive, what can we conclude? From fourth condition, you conclude that A squared minus 3B squared is positive. Because look, the product should be positive. If A is positive, so the next one also should be positive. So we conclude A squared is greater than 3B squared. Now, because I want to say, so this one is positive. Why? Because if we multiply by 3, because here we have 3a squared. If we multiply by 3, 3a squared is greater than 9b squared. Here is negative b squared. So you can say 9b squared is greater than b squared. A and b cannot be 0. Why? Because if a or b be 0, then this or this won't be positive. So a and b are not 0. Because a and b are not 0 and a and b are integers, so we conclude that 9b squared is greater than b squared. So we conclude 3a squared, if we consider this part and this part, 3a squared minus b squared is positive. And because of fifth condition, 3a when 3a squared minus b squared is positive, b has to be positive also. Because the product is positive, this part is positive, so this part has to be positive. So we've proved that if a is positive, b is also positive. Also, you can prove that if b is negative, a negative, but it's not useful. I should prove another thing. I want to prove that both a and b, both of them should be positive, or both of them should be negative. Now, next part, I say suppose if, for example, a is negative and b is positive. Okay, we want to consider it. Then I consider a equal to negative a1, which, because we know a is negative, so a1 is positive, and we know b is positive. Now I want to rewrite it in terms of a and b. So the fourth condition, because a is negative a1, so it will be negative a1 squared minus 3b squared is positive. So if you multiply by negative 1, a1 times a1 squared minus 3b1 b squared is less than 0. For second one, we know that b times 3a1 squared for fifth condition. B times 3a1 squared minus b squared is positive. And in next step, because a1 is, we know is positive, we conclude a1 squared minus 3b squared is negative. And from here, because b is positive, here because a1 is positive, here because b is positive, 3a1 squared minus b squared is positive. And for example, if we consider sixth condition, so from sixth condition, we can say instead of a, I write negative a1, so it will be b minus a1 times a1 squared plus 4a1b plus b squared is less than a1 squared plus b squared. Okay, now here this part is positive because a1 and b are positive, so we can say b minus a1, absolute value of this, times exactly this part for a1b plus b squared is less than a1 squared plus b squared. We know that this part is because b is positive a1, so if b is not a1, so we have two cases here. In case one, if b is not a1, we reach contradiction because this part obviously a1 be positive is greater than this because we have this term more than this. So we conclude two cases. If b minus a1 is not 0, then it is at least one absolute value of that. Then a1 squared plus 4a1b plus b squared will be less than a1 squared plus b squared. You can cancel this with this. So a1b is less than 0 contradiction. So we conclude b should be equal to a1. If b equal to a1, if we consider this one, it is our fifth one. So in fourth condition, you can replace a1 with b with a1. It will be a1 squared minus 3a1 squared is less than 0. So negative 2a1 squared less than 0, and we know a1 is not 0. And also, it's not important that a1 be 0 or not because it cannot be less than 0. Let me check. Yes, sorry. It's obviously less than 0. So let's see this case. Okay, I think it's good. So in this case, let's consider because a1 is equal to b, we know p equal to a squared plus b squared. It is a1 squared plus b squared. because a1 is negative a. So it will be what? It will be 2a1 squared. So the only possible case for this, because p is prime, is p equal to 2. Okay, but we want to find largest p. So here p2 is not largest p. We will find some p is greater than 2. Okay. So in this case, we've reached p equal to 2. Now, let's consider if a less than 0, b positive, it is this. So let's write all cases of a and b. A and b can be positive, 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 negative, negative, positive, negative, negative. What we said here, if a is positive, b should be positive. So if a is positive, b should be positive. So we can cancel this case. In the next place, a0 less a negative b positive, also it's not correct. A negative b positive. So we have two cases, both of them positive, both of them negative. Now I want to prove it is not important to consider both positive, both negative. We can say without loss of generality, we can consider a and b positive. So let me prove this part. Okay, our conditions are this 4, 5, 6. We want to consider both cases. If a and b positive, what happens? If a and b both of them negative, what happens? So first case, when a and b positive, by sixth condition, we can say a plus b times absolute, because a and b are positive, a plus b positive, we can take it outside absolute value, times absolute value of a squared minus 4ab plus b squared is less than a squared plus b squared. And for the fourth condition, because a is positive, you conclude a squared minus 3b squared is positive. From fifth condition, because b is positive, 3a squared minus b squared is positive. So you can conclude a squared is greater than 3b squared. And also 3a squared is greater than b squared. Now let's consider the case that they are negative. So you can say a is negative a1, b is negative b1. And in this case, a1, b1 are positive. So from fourth condition, let's consider again. From sixth condition, you can say instead of AB, you can replace them with A1, B1. It will be A1 plus B1 times A1 squared minus 4A1 B1 plus B1 squared is less than A1 squared plus B1 squared. From fourth condition, because A is negative, so you can say A squared minus 3B squared should be negative. So A1 squared minus 3B1 squared should be negative. From fifth condition, because b is negative, so 3a1 squared or 3a squared minus b squared, it is equivalent to 3a1 squared minus b1 squared is less than 0. So here we can conclude that a1 squared, let me write here, a1 squared is less than 3b1 squared. We switch left hand side, right hand side, a1 squared. Let me write like this first, do not make a mistake, less than 3b1 squared, okay? So I switch left hand side, right hand side, 3b1 squared is greater than a1 squared. From here we conclude 3a1 squared is less than b1 squared. So we can say b1 squared is greater than 3a1 squared. Okay. So as you can see, here the condition here is exactly same as this. And this condition, it is for ab. It is exactly for b1, a1. Okay, b1 greater than 3a1 squared. It is similar to this one. This one, 3a squared greater than b squared, is similar to this one. Okay, so because both of them are similar, exactly, we can say without loss of generality, we can consider a and b are positive, so we can consider all these conditions. Okay, if we copy and paste the conditions, we have these things. A, B are positive, and the conditions 4, 5, 6 will be like this. Okay, because A and B are positive, we can conclude from A, this one, A is greater than B root 3. From this one, B is less than A root 3. Okay? So, for example, from here, you can conclude A is greater than B over root 3. But because this says B A greater than B root 3, A greater than this, A greater than maximum of B root 3 and B over root 3. You know B is positive, so B root 3 is greater than B over root 3. So we can say 4 and 5, if we combine them, we see that only you need to consider A is greater than B root 3. Let's consider this as condition number 7. And we have condition number 7 and 6. Okay, now we should focus on these two conditions, 6 and 7. Because here, if you see the degree is 3, all terms, the degrees are equal. Here, the degree is 2. Because A is greater than B root 3, you can write A in terms of B, and we can cancel many A's and B. How? We say A equal to, suppose, BK. So we know BK is greater than B root 3. So it is equivalent that K is greater than root 3. And if we replace it here, it will be BK plus B, absolute value of B squared K squared minus 4 B squared K squared B squared B cubed. Sorry, let's check. No, B squared K, because A is BK, plus B squared is less than B squared K squared plus B squared. If you divide both sides by B squared, left side will be K plus 1. This one, if you factor from B, we can take B outside, times B, it will be K squared. We can take B squared outside and divide by B, because we should divide by B squared, B from here, B from here. So K squared minus 4K plus 1 less than, if we divide by B squared, it will be K squared plus 1. Now, we can say what? If we divide both sides by K plus 1 times B. K is not 0, K plus 1 is not 0 because K is greater than root 3 and B is not 0, so we conclude K squared minus 4K plus 1 is let's say, is less than 1 over B, K squared plus 1 over K plus. And then we can say inside absolute value, it is K minus 2 squared, but because it has plus 4, we want to reach plus 1, minus 3 less than 1 over B times K squared plus 1 over K plus 1. Okay? Okay, so we consider it as 8th condition. And another thing, from 7 we said A is greater than B root 3. So from 7, because we know A is greater than B root 3, we know that A squared plus B squared is P from assumption of the problem. I think it was second condition, yes. From second condition, so P is less than 1000 from assumption of the problem, so we can write, because A squared plus B squared is less than 1000 and A is greater than B root 3, A is greater than 3A squared, so it will be 3A squared plus B squared. Sorry, A is greater than B root 3, so A squared is greater than 3B squared. 3B squared plus B squared, which will be 4B squared. And because it's less than 1000, so B squared is less than 250. And B is positive, so B is at least 1 and at most 15. If we check, for example, B 15, 14, you will see you reach same contradiction. Okay, and if you continue, you will see up to 9, you will reach same contradiction. So let's consider if B is greater than equal 9, I want to reach contradiction. Then we know that A squared plus B squared is less than 1000. A squared plus B squared is less than 1000 from second condition. And then we know that because A squared, B squared, B is at least 9, so it will be A squared plus 81 is less than 1000. So A squared is less than 1000 minus 81. So it will be 919. So A is at most 30. Okay. Now, we know what? We know that A was bk. A is greater than b root 3 from 7 condition. And also, let's consider this one, for example. Do we have 8? We had 8th condition, yes. So we call it 9th condition. So from 9th condition, it is less than 30. Less than or equal 30. Okay. So if you divide both sides by b, all three sides by b, root 3 is less than k is greater than equal 30 over b. And because b, we said if b greater than equal 9 here, we can say it is less than or equal 30 over 9. Because 1 over b is less than 1 over 9. From here, we can conclude 1 over b less than or equal 1 over 9. Okay, so 30 over 9 this. Now, from the condition here, we've reached 8th condition. Okay, let's copy 8th condition and let's paste it here. So we know k is between these two numbers. We want to see is it possible or not. Because b is greater than or equal 9, so 1 over b less than or equal 1 over 9, so it is less than or equal k squared. So let's write 1 over 9 first. 1 over 9 times k squared plus 1 over k plus 1. We want to see is it correct or not. Here we can say this part is, because k is greater than root 3, we can say it is less than 1 over 9 k squared plus k is greater than root 3, so k is greater than 1. So instead of 1, I can write k, because k is greater than 1 over k plus 1. Why I written like this? Because then I can cancel k squared plus k is k times k plus 1. So if you cancel, it will be 1 over 9 times k, or k over 9. Now, we know k is at most 30 over 9. So we can say it is, so 30 over 9 also, we can write it as 10 over 3. So it will be 10 over 3 over 9. It will be 10 over 27. Now I want to reach contradiction for this part. K minus 2, we know k is from root 3, 10 over 3. Okay, so k is from root 3 less than or equal 10 over 3. It is around 3.3, we can say this. It is exactly this, 3.333. And root 3, okay, so root 3 is around 1.7. So when you subtract by 2, k minus 2 is around 1.33, so on. It is greater than, it will be around negative 0.3. Okay, it's not important, 0.3 or 0.2 or 0.4. You will see. So, because this part is important, we want to calculate k minus 2 squared. K minus 2 squared is at most 1.33 squared. But because look, we have k minus 2 squared minus 3, let's do something. Okay? It says this one should be less than or equal 10 over 27. So I want to find minimum of this part and see if we calculate minimum, is it less than 10 over 27 or not? Okay, so we will see instead of 1.333, we can say, okay, 10 over 3 minus 2, which will be 4 over 3. It's easier to write that. So 10 over 3 minus 2 is 10 over 3 minus 10 minus 6 over 3, which will be 4 over 3. So we can move it here. We can see that it is at most 16 over 9. Okay? It is 1 point something. And if you want to consider minimum of this, it's better that k minus 2 squared be 16 over 9. Because if it is less than that, when you subtract by 3, it will be greater. So the minimum that we want to find is k minus 2 squared minus 3. The minimum is 16 over 9 minus 3 absolute value. 16 over 9 minus 3 absolute value. And we know here it's, because here we have strictly less than, it's less than 10 over 27. But also if you write less than or equal, we will reach contradiction. Because 3 is greater than this, it's 3 minus 16 over 9. If you had question in any part, as I said before, feel free to send message to my WhatsApp number in the description comments. 10 over 27. So if you write 9, then it will be 27 minus 16. It's 4 plus 7, 11. And if you multiply by 3, it will be 33 less than 10. And that's a contradiction. Okay. So we've understood that if b is greater than or equal 9, we will reach contradiction. So we conclude b is at most 8. And because b is positive real number, b is greater than or equal 1. Okay, we had also that a squared was greater than 3b squared. So look, one way is to check, and we know p is what? P is a squared plus b squared. Let me tell you how to check, for example, one case. And one of the conditions that was important, eighth condition. We have here a is bk, and another thing we should pay attention. Okay, we've written all of them. A, B are positive real numbers, so at least one. And okay, we've written. And so, because look, p is a squared plus b squared, a and b shouldn't have any common factor because p is prime. If, for example, GCD of a and b be 2, so it is multiple of 2, multiple of 2, multiple of 4, so p should be multiple of 4, impossible. So if GCD of p d a b b d, so a squared is multiple of d squared, b squared multiple of d squared, so p is multiple of d squared. So we conclude d is 1. Okay. Now let's analyze. For example, I consider case 1. You can start from b8, b7. You can check all of them. Let me tell you how you should check. If b equal to 8, by this condition, we know a squared is greater than 3b squared. 3 times 64 is 192. So we conclude a is at least 14. Because 13 squared is 169, 14 squared is 196. And because b is 8, a cannot be even. So for this case, if we write a can be, for example, 15, 17, 19, 21, 23, 25, 27, and 29. We know a is at most 31. 31 squared is 961, but because b is 8 squared, b is 8, b squared is 8 squared 64, it will be greater than 1000. We know by assumption of the problem, a squared plus b squared should be less than 1000, so maximum a is 29. So by considering mod 2, we rejected even cases. For example, we consider mod 5 and mod 13. Let me tell you how we can understand. Mod 5 is easy. Mod 3, if you consider mod 3, b squared mod 3 is 1, a squared mod 3 is 1, 1 plus 1, 2. It's not multiple of 3. Also, for example, if a is multiple of 3, 0 plus 1 again is not multiple of 3. But if you consider mod 5, then b squared mod 5 is what? 64. Is 4 or negative 1. So a squared mod 5 shouldn't be 1 because then their sum is multiple of 5. So we conclude a shouldn't be plus minus 1 mod 5. Okay? So by this criteria, we can say, okay, it's minus 1 mod 5 plus 1 mod 5 minus 1 mod 5. We rejected this case. And then if, for example, you calculate 27 squared, you will see, okay, mod 13, there are 0. So let me calculate mod 13. So look, mod 13 is not by guessing. When you calculate 8 squared plus 27 squared, you see mod 13 is useful. So let's see what happens. B squared mod 13 is 64. 64 is negative 1 because 5 times 13 is 65. 65 is multiple of 13, so it is negative 1. Now, if A is 27, so mod 13 is 1. Okay, so for example, one thing that we understand, a mod 13, a squared mod 13 shouldn't be 1. So a shouldn't be plus minus 1. Okay, now with new criteria, we reject 27. Also, we reject 25. Okay, if we check 15, 8 squared plus 5 squared, 8 squared plus 15 squared is 64 plus 225. If you add, it will be 289. And this is 17 squared, it's not prime, so we can cancel also 15. 17 and 23 are left. So I will reject 17, then 23 will be same, and then you can reject the rest by yourself, and I will tell you, you will find what answer. Suppose, for example, a equal to 17, b equal to 8. So b squared is what? 64. A squared is what? Is 289. And if you check a squared plus b squared, you will see it's prime. It's 4 plus 9, 13. We have 1. It's 5, and it is 3. It is prime, but we should see that it should satisfy all conditions. So this condition okay, this condition okay, is greater than a squared 3b squared. This condition okay, we should see only 8th condition. So when you see some cases prime, you should only check condition number 8. Okay, so let's copy that. Let's paste it here. So K here is what we know. A is BK. Okay, A is what? A is 17. B is what? B is 8. K, so K is 17 over 8. If it satisfies this condition, then it will be so. Let me tell you something. It's better to check first 23, okay? But if you also check 23, you will see reach same contradiction. So let's replace here. K minus 2 squared is 17 over 8 minus 2 squared minus 3, okay? And less than 1 over 8 is b is 8. 17 over 8 squared plus 1 over 17 over 8 plus 1. Now here, if we calculate this, it will be 1 over 8, this part, squared. It's 1 over 64 minus 3 less 1 over 8 times 8 squared 64, 17 squared 289 plus 64 over 17 plus 8, 25 over 8. 8 will be cancelled. So here, if we calculate 3 times 64 is 192, minus 1 is, it's negative 191, but because absolute value, you can say 191 over 64 less than 289 plus 64 is 3. We have 1, 6 plus 8, 14 plus 1, 15. We have 1, 1 plus 2, 3 over 64 times 1 over 25. So if we cancel 64, then it is equivalent that 25 times 191 is less than 353, which is obviously wrong. Because if you also multiply 191 by 10, it will be so much greater than this. Okay, so you can reject these cases. Okay, if you reject these cases, you will see in B5, you will reach an answer. B5, A18. You will see it satisfies all conditions. And after that, because P is what? A squared is 324 plus B squared is 25 is 349. After that, if you reach, for example, some case that is prime but less than 349, you can reject that quickly. Why? Because we want to find maximum P. So it is 349. And our answer will be this. If you have question for rejecting other cases, or I can say the hardest problem of this exam was this. If you had any question about this, about rejecting or other cases, I tried to explain all parts completely with respect to our time. The last part only checking. I told you, for some consider which mods, and the strategies I told you can generalize for other cases. If you had question about this, or if you had question, as I said before, there are around 40-50 important formulas in geometry, some important ideas in combinatorics, like caseworks, like 3 important ideas in paths, numbering, permutations, levels. You should learn them. They are useful in AMC, AIME in next levels, USAMO and IMO. And also in number theory, for example, when product of two numbers equal perfect square, you should consider GCD. It has a famous form. Some general topics you should know. They are useful also for summer camps in USA, for Stanford University, SUMAC, for Promise, for Boston University, also for applying top universities like Cambridge. the exam CSAT or something like this. If you want to learn important ideas, for example, like BMO or British Mathematical Olympiad, if you want to learn them, as I said before, feel free to send message to my WhatsApp number in this description and comments. Okay, have a good day. Bye.